1 2 2 1 2 sa 1 2 2 2 check check 1 2 check check sa. I'm seeing it on your monitor. 1 2 2 2. You need more gain? One, two, check, check, 1 2. Check the rec, check the rec. 1 2. And then it should be fine.
Still see the slides. Can you hear me if I'm this close, or am I past it? No, I'm just wondering if that's too much. Because I also don't want to pace outside the... So also, where the video, how far over? Because I actually don't want to get outside the video feed. So can you hear me here? Always. What's the side? I mean, for Okay. Let's, for me at least, the handheld. How far over can I go while still being in the picture? Am I still in the picture? Oh. Okay. Keep going. Keep going. Oh. Well, once I hit there. Okay. So hit the screen. Screens. Okay. Okay. So I'll just stay in the middle and I'll use the hand mic. I'm good with that. And then that way other people know that that's the boundary. I guess they don't need to hear me now. One more thing. Now that's coming from these mics. And this is one more thing coming from the handheld mic. Which sounds better? Oh, okay. Okay. So it doesn't matter if people in the room can hear me or not.
Well,
The people out in the internet can't hear me.
that's the point, yeah.
Yes.
So maybe it's what you wrong.
Yeah. I'm a little egotistical. Is that what the word is? That sounds weird. Yeah, I want everyone to hear me. Not just in this room.
1, 2, check, check.
Hi, everybody. If I talk loudly and slowly, I might entice the hallway track to walk in. No, I already got out there and yelled. So. I'm just going to go ahead and start the opening. I'll remember to close these doors before Troy starts talking. So anyway, welcome to CentOS Connect. Welcome back for those of you who have come the last couple of years, or welcome to the first time if it's your first time. I want to start out by thanking our sponsors. We've grown this into a 2-day event, and we're able to do that because of our sponsors. And so Red Hat and Fedora, and then also AlmaLinux, Rocky Linux, and Meta have been very good sponsors for us. So I want to thank them starting off. So. Some housekeeping notes. We have all of the rooms here on the first floor. This whole space is ours both days. You'll notice we have all these other meeting rooms where we had the meetups this morning. The Birch room, which is in that far corner, is staff and speakers only, please. But the rest of the rooms, the 2 Buckeye rooms and the Elm room, now that the meetups are over, they're open. If there's nothing on the schedule, I know a lot of times, people just have conversations. We work hard to make a good hallway track here, and sometimes it's nice to maybe take your conversation into a room where you can sit down. If one of those rooms is open, if nobody has kind of staked their claim in it, you are welcome to go use any of Buckeye 1, Buckeye 2, or Elm for any impromptu meetings you might want to have. But again, Birch is staff and speakers only. We are having I have in no particular order my notes, so it's very disorganized. If you didn't get the email, if you did get the email as well, there's still a waffle party tomorrow. It will be at 8:30 p.m. at a waffle place. Is Fabian in here? What's the name of the place so I don't say it stupidly?
I think it's Gaufre de Bruxelles, so it's near the Grand Place.
Gaufre de Bruxelles? That was terrible, yeah. Anyway, it's near Grand Place. The address is in the email. In tomorrow's closing, I'll have more information. Maybe I'll put a slide up with it, like a map on it or something. It's super easy to find, though. It's really close to Grand Place. So we have details for that. Everybody, it's not a dinner thing. It's at 8:30, so you can go have dinner on your own and then join us. And we'll be doing a waffle and drink for everyone, and we can all hang out. Yay! I love waffle parties. A note for our remote attendees. We do live stream this event, and we try to include the remote attendees here. I should look into the camera as I say this. We try to include our remote attendees here, and we will try to relay questions up to the speakers. However, there is like a 5-second delay on the live stream. So if you wait until the very end to throw in that last-minute question, the speaker might already actually be down from here by the time I see it and I'm able to relay it to them. So ask your questions as you think of them, and we'll relay them, time permitting, of course. There is a Fedora badge, if you didn't see it. If you like getting your Fedora badges, we have throughout the outside area out there a few like QR codes. You can scan them and get a Fedora badge to show that you were here. And I will mention for those of you who are attending FOSDEM, which I imagine is everybody, There's a distributions dev room on Sunday where you can hear more stuff about all sorts of distributions. And Troy Dawson will be speaking in the distros dev room about CentOS, so you can come hear more CentOS stuff. For speakers, a reminder, use your microphones. If there are audience questions, we have microphones to pass around, so please do questions on the microphone. Or I know sometimes like someone's in a corner, it's easy to just shout something out, but the live stream can't hear that. So either say it on the microphone, or a speaker, you can just repeat the question into the microphone. That way we have it on the live stream and we have it on the recordings. When I introduce you as a speaker, the camera's right here. And so if I introduce you and then you immediately start talking, I have to walk back there to the desk. And so if you start talking immediately, your recording that will live forever on YouTube will start out with me walking into this camera, and it looks terrible. So just wait like 5 seconds until I get back there. And audience, you could help this, just applaud when I introduce the speaker. And then that'll keep them quiet for a few seconds while I go back there. Speakers, remember your time. Most of you have a 25-minute slot. Some of you have a 40-minute slot. I actually have a timekeeping thing here because there's no clock back there. And that's something people have said in previous years. They want to know what time it is. So microphone for the questions we already said. Awesome. That's everything that I was going to say. And we are 3 minutes ahead of time. So why don't we just get started? I'm going to introduce our first speaker, Troy Dawson. Troy has been creating Linux distributions for 25 years, which is right about as long as anyone's been creating Linux distributions, I think. He's been helping create RHEL since RHEL 8. He's now on the CentOS stream and the emerging RHEL team that's creating RHEL and CentOS Stream 10. And he's going to come here and talk to us today about CentOS Stream. So Troy, thank you for joining us.
Thank you very much. My name is Troy Dawson. For those who are wondering, this is the CentOS Stream 10 background. So I've had a couple people ask, what is that? That is the CentOS Stream background. That is not part of my slides. Anyway, as Sean said, I'm part of the CentOS Stream and Emerging RHEL team. I'm giving this talk on behalf of Adam Samalik. He originally proposed it and all that, and he told me he's watching. Adam, you should be watching out here. But he also told me he was going to try and help me with my slides while I was giving them. So we'll see what happens when he does that. I hope he's remoted in good enough. Here we go. It all starts with Fedora. And what is Fedora? As Adam says, Fedora is a blue box. No, that's not really what it is. It's got lots of things. Oh, there he is. Adam's in there. Fedora does lots of things. It's got servers, it's got IoT, it's got game things and stuff. But we're not here to talk about Fedora. Okay, Fedora every 3 years becomes RHEL. And in the past, that was like behind closed doors and we couldn't talk about it. There was the famous rocket with the infinity symbol on it. And that wasn't good. That wasn't good. And then we decided to do it in the open. That was with RHEL 9, CentOS Stream 9 days. And Fedora, when it became CentOS Stream, became RHEL. But we also don't want to talk about RHEL either. So what is CentOS Stream? CentOS Stream is a Linux OS maintained by RHEL engineers. That's a interesting thing. Oh, yeah, we are going to talk about Fedora. Fedora gets branched every 6 months. 37, 38, 39, 40. We're almost to 42. And as Fedora gets built, these ELN packages happen, and an ELN distribution happens. ELN is basically Fedora Rawhide packages with the RHEL flags and triggers and all that stuff happening in them. And as we said before, every 3 years or so, we branch it off, we get CentOS Stream, and that turns into RHEL 10. Let's look into this a little bit more. So ELN, we're going to look at the CentOS Stream 10 thing. I'm going to look at the slides, whichever way you think I'm looking. We start with ELN, CentOS Stream 10, and when we branch CentOS Stream, we got this bootstrap phase where everything's going. We keep things in sync with Fedora, and that's sort of so we can get everything set up. We can get the initial things, a few mass rebuilds in there, and then we cut it off. And ELN becomes CentOS Stream 11, and we then proceed this pre-release phase. The maintainers say, no, we don't want that. We do want this. Oh, this package should look this way and thus forth. And then, well, let's see, where are we now? We're here. So at some point, CentOS Stream gets released. And with 10, that happened in December. So we were all excited about that. Apple 10 got released. Sorry if I'm stealing your thunder, Carl. But Apple 10 got released at the same time as CentOS Stream 10. At the same time that the CentOS website got updated, it was a grand release. It was wonderful, and nobody noticed probably. So, there we go. And we still are maintaining CentOS Stream 9, and CentOS Stream 9 is continuing to make RHEL 9. So how does this workflow go? I'm going to go into a little bit more detail. So there's three main things. We got our sources, we got our builds, and then we got our releases. The sources, CentOS Stream sources are always synced with RHEL. When something gets checked into CentOS Stream, it automatically gets synced over to RHEL. Our RHEL maintainers have been taught since CentOS Stream 9 and RHEL 9, CentOS Stream first. That's where your code goes. That's where your merge requests go. Builds are sort of coupled. Adam trademarked that phrase, sort of coupled. And then releases are not coupled at all. Sorry. Yeah, Jira. Sorry about that. Issues.redhat.com, that's where the Jira tickets are. We'll just call them issues. Let's just leave that word out. Issues, but this is where you can talk to the maintainers. You can open up a bug, an issue, and tell the maintainer, hey, I want this or that. But anyway, so everything begins there. It's, the European elevators start with 0, so does this. But we really want to talk about the sources. When the source gets checked in, this is sort of what happens there. We get a merge request, and the merge request goes through testing to make sure it's a sane merge request. I'm not saying that outside people do insane things, but sometimes even the RHEL maintainers. Anyway, tests are good. When they get merged, they immediately get merged over to the RHEL dist-git and RHEL source. This is sort of what it looks like. This is a systemd merge request. 5 days old. So here's where the testing happened. Those are all Zool. They're currently being tested by Zool. And so if we look at changes, we see this resolves RHEL blah, 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 the RHEL issue number. If we look at that, there we go. We have a RHEL issue number. This was done by Pat. Sorry, Pat, I can never pronounce your last name. This is Patrick. And he said, hey, yeah, you guys can pronounce his name. And anyway, but he issued this thing. The RHEL maintainer says, yes, this was good. He made that merge request. And in it goes. And there's our merge request. And it goes into this. We're using GitLab now, in case people don't know. We're using GitLab. It goes into the systemd. There's the files. So if you look at the files, we see we got our spec file there. The sources up there, been asked about sources. Is that really the sources? And it's like Fedora's sources. No, that's not a source. That's really a hashtag that says where to get the source. So how do you get the source? Yeah, I'm sorry, Adam. This just isn't going to work. I'm just going to fast forward through this. Do you guys, people have seen this before. Adam's trying to type on this screen. It's just not going to work, Adam. Sorry. Go, keep going. What he's really trying to show you is how to use cent package to get the sources. You can use cent package to get the source RPM. It didn't turn out very well. How many? There we go. There we go. Okay, it exploded this time. He didn't get it to explode last time. Anyway, there's ways to get the sources, and I'm not going to show it to you, but use cent package. You can use it in the container, the Fedora container, cent package source RPM. Okay, builds. We've looked at our sources. We're going to look at the builds. Builds are sort of coupled. What does that mean? When a build starts, when the maintainer kicks off a build, unfortunately, if you guys are not RHEL maintainers, you cannot kick off a build. But when they do kick one off, if it builds, it kicks off a RHEL build. And both of them go through gating. And they get this gating tag. Actually, before they go through gating, they get a gating tag. Tags are Koji-based things that tag packages, and it helps you helps you keep track of the builds and packages. So they get a gating tag. They go to gating. If they pass the gating tag, they go to candidate tag. They get a candidate tag, and that's special. And then the CentOS people, they don't do anything, but the RHEL maintainer can look at it and go, yeah, I do really want this build in my release, and put it on a RADA. Those of you who follow RHEL packages very much, you know what erratas are. Otherwise, I'm not going to explain it because it's not a CentOS stream thing. So anyway, they get the RADA, they both get this pending tag, and then they go on their merry way. And this is sort of what it looks like. This is the CentOS stream build things. Here we see we've got Firefox built here, and Firefox has this tag C10S gate, C10S candidate, and at some point the maintainer says, yes, Firefox is really going to be in CentOS Stream 10, and he marked it CentOS Stream pending. And those of you who are in the know might think this is a little strange. So yes, I am going to officially announce Firefox is in CentOS Stream 10. So some people were asking me, what are you going to talk about? I was like, I'm not going to tell you. That was one of them. Okay, Firefox is in CentOS Stream 10 as of 2 weeks ago. It was in last week's release, and we'll see more about that little tidbit. Okay, what happens at the release? There's composes, there's testing. Yeah, Adam's back on. Okay, what's in composes? Well, composes have repos. Adam, you know there's a slide like 2 things down that tells all this. You don't have to tell me that. We have composes, and then those composes get tested, and then if they pass the tests, they get released to the mirrors and stuff. But let's talk about tags. We already saw the gate, candidate, and pending tag. If you were observing on that other slide, you might have seen another one. Let's guess what they are. Pending dash signed. Yeah, it's signed. It's now signed. There's another one that you actually won't ever see because it's just in definitions. It's composes. It's basically the latest pending release. And everything from, when we make composes, we make 2 composes. We make a development compose off of candidate that allows maintainers to test things off of that. But you guys are probably more interested in the production compose, because the production compose then gets tested, and if it gets tested once a week, we push it to production. So what does that compose look like? Okay, I told you it was going to be in here. We got RPM repos, the main ones, of course, base OS and AppStream. We also got CRB. I'm not going to tell you what that stands for. Make it up. But then we got these little smaller ones that most people don't use, but they're still there. High availability, lots of acronyms. And then we have images. DVD ISO, that's a big 8 to 10 gig big thing. And net install, containers, AWS, all sorts of fun stuff. And if that isn't enough, then there's more. There's an alternative images SIG. That's a cool SIG. I like that SIG. Great. Wait, we went backwards. Tell us more about the testing. Okay. Alan wants to talk about testing. Testing is currently being done by CentOS integration SIG. That's a SIG again. I've noticed that twice in here. When we do a compose, they go in, yes, it's being tested on Jenkins. CentOS Stream 9 is still being tested in the, I always have to look at this thing every time. It's still being tested in the same way that it was for 15 to 20 years when Johnny started this stuff. When CentOS started this stuff. Johnny didn't start CentOS, but he's been around. Anyway, so it's been around since that thing. CentOS Stream 10 is using the new format done by the SIG. It's called TMT. Others can explain it a lot better. We have green and we have a few red ones. So it's still being worked on, but we do have enough green ones to let us know when we got a good compose and when we got a bad compose. Here's the SIG page that explains all about what the SIG is, and here's the SIG page about their testing. And here is their GitHub, GitLab place where the composes are, and I wanted to especially thank Carlos for doing this. He's done a vast majority of the work, if not all. I'll just say vast majority because I think a few others have helped him. Anyway, thank you, Carlos. And that brings us to SIGs. Oh, sorry. I heard an applause from the thing. So thank you, Carlos. And to be honest, doing testing and stuff is a thankless job, and we should thank them much more. But it also brings us to the SIGs, CentOS SIGs, Special Interest Groups. I'm sorry for using the acronym before saying what it was, but that's what CentOS SIGs is. CentOS Project. CentOS Project is a rectangle. It is not a square. It is a rectangle because it has lots of other things on top of it. There's CentOS Stream, but then there's all these SIGs, the hyperscale artwork, alternative images, cloud, automotive, I can't even see that, and several other SIGs. And the SIGs have two build systems. We got again, he knows that this is coming up, and he keeps hacking in here. CS Koji and CBS Koji. Guess what those stand for? Yeah, Adam knew this was coming. CentOS Stream Koji is read-only outside for Red Hat. That is where we build CentOS Stream. It's all public. You can see everything, but it is read-only outside of Red Hat. Sorry, wrong button. Community build system is where the SIGs build. They build packages, they build images, they build all sorts of stuff on the CBS. And it's a great place. And I talk about thankless jobs. There's a person in the audience that maintains those, and he is a wonderful person. So thank you, Fabian, for keeping those things going. So the CentOS SIGs, we have a governance page. We have things that talk about how to get them they grow like a little tree. Basically, anyway, how to create a new one, how to retire the things, how to join your own. Yeah, okay, how to join. Let me, I'm going to stick on 6 for just one more minute. I think my time is, you didn't actually start that. I was like, my time is up. But how close am I? Real, well, anyway, 10 minutes. Oh, we're good. We're good. Joining the SIG is dependent on the SIG. Membership is dependent on the SIG, but most of them are fairly easy to join on the SIGs. Okay, for this audience, I'm going to talk about CentOS Stream contributions. Can you actually contribute to CentOS Stream? So this is all the SIGs and stuff, but we're going to concentrate on the CentOS Stream part for this. So the answer is yes, with a big caveat here. CentOS Stream source is RHEL source. RHEL is a product of a company, an enterprise-based product of a company, and there's things that they want to keep stable. They have this application compatibility guide. That's a fun app thing. There's documentation on the applications compatibility guide. There's lots of stuff. It says things like API, ABIs, all sorts of things. Compatibility level 1, 2, 3, 4. It's a in-depth thing. Pat also has given a talk on this one, and if you really want to know more about it, in short, don't break things. That is what Red Hat has promised their customers, is to not break things with the API compatibility thing. There's another thing you have to think about, and that's the Red Hat life cycle. Again, more pages. It's got lots of charts and tables and stuff, and more stuff. Extended life, maintenance life, and there's this looks nice. A nice little graph here. Let's zoom in on that. So every 6 months there's a release. So, and then you see that big long one that usually is end in 9.10. There's a big long thing that it stays there for a long time. That's when it's in maintenance release. CentOS Stream does not have these point releases. There's actually nothing to indicate when it branches off. That's for good or for bad. Those of us who use CentOS Stream long term, hey, it's actually sort of nifty that I don't have to worry about my stuff doing a point release. Anyway, the Red Hat Enterprise Linux lifecycle is also something you have to consider when trying to get things into CentOS Stream /RHEL. But it is possible, and it all starts with 0, the JIRA ticket. Oh no. But talk to the maintainer first. That's really a good thing. The second thing is do a merge request. That isn't always what the maintainer wants, but sometimes it helps. And the third thing is it's the maintainer that decides whether something goes in or not. That's their job, and they're doing things. So what sort of things can go in? Bug fixes. If you have a bug, it doesn't break API compatibility to get fixed. Go ahead. Tell the maintainer there's a bug. If you have a fix for the bug, go ahead, do the thing with the word we will not mention. What other things? Stable updates from upstream. This is an interesting thing, because what is the word stable? Well, first off, it can't break those ABI compatibility things. If it does, it is not considered stable. I'm going to leave that to your imagination. We could stay on that one for a long time. Backported features. Sometimes a feature gets up there, but it isn't ABI stable, but the feature can be backported. That's a lot of hard work, but the maintainer might do that. If you help them out, that might help. But also know that things like this is going to take lots of testing, and sometimes things are going to not make it through all the testings. What doesn't do, anything that breaks an ABI compatibility, it's just not going to do, you're going to get a no. Docs, typos, man pages, those are always really nice, but you probably don't know the amount of testing that's going on behind scenes. So if you're changing one word and it takes, 100 man hours to do that, it seems easy to you, but it's not so easy. And so that's why these have a question mark. Don't do them. So more disruptive updates can be done in Fedora, because after all, it all starts with Fedora. That's really the best place to get things into CentOS Stream, especially if you want a major change, is get it into Fedora. It'll make its way into RHEL. And here's the nice workflow. Yes, Adam. Okay. It's easier in Fedora. It's harder in, wait, what about, we'll talk about that. It's harder in RHEL. Sorry, he's a little impatient. Yeah, there's like, what, 20,000 source RPMs in Fedora and 2.5 thousand in things. EPEL. Carl has a good EPEL talk later on in this conference, so we're not going to talk about EPEL. Again, I really like this slide because it sums it all up. Fedora is a great place for getting the latest and greatest in, getting your changes in. It has a 6 months to a year release cycle. CentOS project, changing the actual CentOS Stream and RHEL is going to be harder, but the CentOS Stream SIGs, you can do a lot of things on top of it and manipulating it. And that's what they're for. CentOS Stream has it gets branched every 3 years. It has a 5-year-ish life cycle. And, oh, sorry, that's one thing I didn't know. If you're running RHEL, CentOS Stream is a great way to test and see what's coming down the pipe. Thank you very much. Do we have any questions? We do have a mic if we have questions.
The internet wants to know, since we got Firefox, will we get evolution in CentOS Stream?
No. We are getting, I'll have Thunderbird. Somebody double check. Thank you. We are getting Thunderbird, but it is only Firefox and Thunderbird.
The internet wants to grill you on what's in CentOS Stream 10, I think.
Okay.
Anything about the issue of DNF being slow?
DNF being slow. Depends on your definition of slow. CentOS Stream 10 does have DNF 4 by default. I have been told that maybe some other releases, the DNF 5 might become, but it will never be the default. DNF 4 is going to be the default for the entire release. So if that's what people are asking, the answer is yes, it's going to still be slow. We got one on the pillar, so you can't see him.
Oh, yes. Hey, thanks for the presentation. Do you have a strategy about remote desktop with Wayland for customers that need remote desktop? Is there some plan for that?
Remote desktop with Wayland. So for KDE, yes, I have a strategy. Other desktops, I don't know. That's what EPEL and that's what SIGs are for. Michelle, wait, did I get your name right?
Thank you. To the person who was asking if we can get evolution in EPEL, I'm in EL10. It might be doable in EPEL, so I might try doing that in the future.
Yeah, that is true. EPEL is a great place to put those packages because there's going to be several packages that are missing and people are going to miss. And Apple's a great place. You know, I had to do it for KDE. Now the GNOME people get to step up. Sorry, that sounded rude, didn't it? But the thing is still true. There's always things missing in RHEL. If you really want it, and some of you, geez, look around this crowd. I can't see anybody who isn't a Fedora maintainer. Bring it over to Apple. That's the place for it. Yeah.
More questions?
All right.
Thank you, Troy.
Thank you.
So next up will be Alessandro and Dennis. Are you? Look around. There we go. We'll get you set up, and I'll remember to turn the timer on this time. Is it just you? Oh, I thought you were co. Oh, okay. In that case, I will just introduce Alessandro Di Stefano, who will be talking to us about. They had a very long title, and I only have half of it. Leveraging the Kubernetes NQ scheduling plugin for smarter workload placement. Alessandro, thanks for joining us. Please welcome Alessandro.
I will see from there, if possible. I don't know if I'm visible in the cam from here. Am I? Okay. So welcome everybody. I'm Alessandro. I work for Red Hat in the OpenShift on multi-arc team. What I'm going to present is a work that we are doing, starting from the experience that we have had in releasing and in building and releasing the multi-arc tuning operator in OpenShift and Kubernetes. I will start from how many of you are or are not familiar with Kubernetes OpenShift in this room? Okay, how many are familiar with multi-arc OpenShift? Right, well, I mean, if you are familiar with Kubernetes, it's easy to imagine what a multi-arc Kubernetes is or multi-arc on OpenShift is. It's a cluster that is capable of running multiple workers that can have different architectures. The reasons behind running such type of clusters are, running workloads that are optimized for a specific architecture or having the possibility of migrating from one architecture to another, and then scaling down workers of a given architecture. And among the various key enablers of this cluster setup, there are multi-architecture container images. I'll try to be very synthetic on this. If in this presentation we can consider a container image being a read-only file system composed of layers with binaries that we can build. A container image is usually defined, is usually referenced in a manifest, a JSON object that can essentially get that, that points to each different layers. And you can imagine that building such a container image means building a file system that is single architecture and architecture specific. In order to support multi-architecture container orchestrator, one of the key enablers is having the possibility of having images that are multi-architecture, which are essentially images built for different architecture composed into a manifest list, which is another JSON object having a list of items, each one, how can I say, pointing to one of the manifests and having a pair of OS and architecture so that a container runtime can pull the proper manifest and run it into the Kubernetes cluster. Now, the problem is that once you schedule a pod in Kubernetes, the scheduler doesn't know about which architectures are supported by that pod. And that you can essentially end up into two different situations. You can end up in a situation where you have only a manifest, and that manifest will be tried to be run by the CRI. And if you scheduled the pod into the wrong node, you will end up in a crash loopback of the CRI tries to run it continuously based on the restart policy of the pod, and it is just unable to do it. If you have a manifest list instead, and the manifest list has no manifest for the architecture where the pod was scheduled, then you have a different error, image pullback off. The CRI is trying to pull that image and never finds it. The solution to this is that as a user, you can set node selectors, you can set or node affinities in order to instruct Kubernetes about which architectures are supported by the pod that you are running. Again, in Kubernetes, scheduling refers to the capability of placing pods in nodes that can run it. And this is sort of controversial from my perspective, because the scheduler can still place a pod into a node of the wrong architecture unless the user has hard-coded this information, which is also a strictly coupling issue typical of software engineering, because the resource that you are based on can come from an external registry. This external registry can update the image, the provider of the image can update the image in order to support another architecture, and you still think you support only one. Someone can think, let's put this feature within the scheduler, but this feature requires network access. Network access in network scenarios that in Kubernetes can be quite complex, and they cannot be guaranteed always. The network latency is also a problem for the performance of the scheduler. The time to schedule of a pod will be impacted essentially by the retrieval of the information from the registries. And also, there are other problems related to the cluster autoscaling that essentially simulate what the scheduler does and will need modifications as well. What we came out with in the OpenShift on multi-arc team is the multi-arc tuning operator. It's essentially an operator that runs a controller that, well, does this work, inspects the image given a pod that is being created, and does the job that the user should do manually for instructing Kubernetes about which architectures are supported. Basically, the user creates a pods. There is a webhook that inspects intercept the creation of the pod and gate the pod from being scheduled. Once a pod is gated, that pod, the scheduler will never work on it until someone decides to remove that gate, which is the controller, that we run, capable of, essentially, as I was saying, reconciling the pod, as in inspecting the images, patching the pod, adding the supported architectures, removing the gate, and allow the scheduler to place the pod in the proper node. This work is based on a feature that is relatively recent in Kubernetes, which is named scheduling readiness, and another feature also quite recent, which is mutable pod scheduling directives that allow users or controllers, integrators, to modify the pod specifications until they are not scheduled. Well, you can modify the node affinity for setting the architecture, but what about modifying the preferred node affinity and allowing a more dynamic control of where the pod should land? Users are not said to be aware of the workloads that they are running, or better, of the needs that a given workload has, and that those needs can vary over time. A good example for me is the interpod affinity. Let's imagine you have a network of pods that are communicating with each other. If anyone of you is familiar with the clustering algorithms, you can think about optimizing your network of pods such that pods that communicate strictly with each other can stay on the same node and communicate essentially over IPC instead of switches, networks, etc., etc. So that we have started thinking of extending the work that we have done with multi-arc tuning operator, and trying to think at ways to influence the scheduling processes that happen in Kubernetes. Today, in the Kubernetes ecosystem, there are centralized schedulers. You can run the base scheduler of Kubernetes, or you can fork the scheduler plugins, building your own scheduler. There are several schedulers available, third-party schedulers that you can deploy in your cluster. But each one of these schedulers should implement several strategies that the users can then use on a specific pod. What if I want to implement the clustering strategy to optimize the networking between pods, and then a possible strategy that optimize the workload placement based on the architecture, for example? Well, I should modify one of the schedulers that does one of the two things and add the other functionality, meaning that this burden is delegated to the user or to the apps and to the community responsible for one of the given schedulers. So the situation that we have is several pods that run in your cluster, each one pod that can be bound to one scheduler. The project that we are thinking that we want to land into as an OKD initiative, as an OKD community initiative, is named Outrigger, and essentially is framework operator that builds from the experience of the multi-arc tuning operator to provide ways for implementers to dynamically change the pod mutable scheduling directives, and also instruct the autoscalers, the pod autoscalers, or other components like the scheduling for eviction of pods, or sometimes migration, even though it's a bit of a more deep topic. It's named Outrigger because everything in Kubernetes takes from the nautical metaphor somehow. The names are also finishing. We were just chatting about this some hours ago. But Outriggers in the nautical environment is a tool. I'm not from the nautical environment. I wish I could, but I'm not. So if anyone is, please correct me. Outriggers in boats are essentially elements that allow to give more stability to the boats. They are composed of floats that float in the water, struts that are the element destroy the structure attached to the boat, and essentially once they are attached, your boat can stay more stable in challenging waters. They are different based on the type of boat that you are running. They are different, type of boat that you are navigating. And somehow they really, I think they represent what Outrigger tries to do based on the challenging water that you are navigating with your container orchestrator. I don't know, HPC workloads, long-running services, multi-architecture Kubernetes clusters, network-intensive workloads. The idea is that we could compose different strategies, binding them to different parts of a single cluster, and influence the scheduling process as well as the autoscaling, the scheduling and pod autoscaling. This is a work that is currently being in progress somehow, that we wish to publish soon and share with the rest of the community. This is the first presentation about it. The idea is to go essentially from that previous environment where there are centralized schedulers that can be bound to pods, to another environment where the centralized schedulers continue to exist. We don't want to replace them at all, but we can interact with them and do some work that users might not be able to do sometimes, or that users cannot just do because, as I was saying, the dynamicity of the life cycle of a cluster can change over time. And again, it's the beginning of an initiative, and if you have any questions or what we would like to understand, if eventually this can have an interest from the community, OKD community, people from the Kubernetes community, cluster administrators that I believe are in this room. Well, questions?
Questions? No? Then thank you. We are running 15 minutes ahead of time. And our next speaker is me. Give me just a second to set up here. Okay, so we are running very ahead of time, and I promise my presentation is not going to even fill the whole 25 minutes. So I'll go ahead and do it, and then we can have actually a really nice long break before our last block of talks. So, hi everybody, I'm Sean, and I'm going to talk to you about the effort that we did recently to revamp our web and our docs. And this is titled Web Revamp. We did it, sort of. So I'm going to take you through some of the problems we were trying to solve, and what we accomplished, and then like what we didn't do, right? Because we wanted to get this stuff published. We were actually trying to do it at the same time as the CentOS Stream 10 and EPEL 10 release announcement. And like if we waited for everything to be perfect, then all of the engineers working on CentOS Stream 10 and EPEL 10 would still be waiting for us to make their announcement, right? And then they'd all get very mad at me. So first, I will take you through some old and busted and new hotness. Some of the things that were kind of wrong with the website and our docs as well, and what we wanted to do. So our old website, which was a nice website, I liked it, but it was designed around this two versions. So there was CentOS comes in two versions: CentOS Linux and CentOS Stream. And as you know, we recently actually discontinued the CentOS Linux 7, which was the last version of CentOS as a rebuild project. So that went end of life earlier this year. And then what we did with the website was that little box went away, and then the box for CentOS Stream was just kind of big there, and it looked kind of silly because it was like it wasn't designed for that. And so what we wanted to do was to showcase Stream as our primary deliverable, but to also talk about some of the other stuff that we do, the stuff that our SIGs produce. So like, you know, Hyperscale produces a variant, basically, of CentOS Stream, or different packages and stuff, and you can just consume CentOS with the Hyperscale stuff. So that's one example, but you know, there's various things that you could run other than just raw CentOS Stream. So we wanted to highlight all of that. Old and busted, our doc site only had a contributor's guide, and it was mostly empty. So it wasn't terribly useful. There was some old contributor information on the wiki, which we took down about a year ago. The SIG docs was actually pretty good. We had it at sigs.centos.org, and a lot of our SIGs, not all of them, but a lot of our SIGs had documentation on it, and they were pretty active in keeping their stuff up to date. So our SIG docs were pretty decent, but they were in another place from our docs. And then we had our infra docs were in another place. So it was a little bit confusing to try to find all of our documentation. We wanted to just have a single doc site where you could go and you could see, here's how I contribute to the project, here's, you know, information about CentOS Stream, here's information about the SIGs and how the infra works. I mentioned the wiki. So, well, last year actually, it was a result of a doc day that we did here at FOSDEM last year, and we went through and said, okay, we've got to take down the wiki. It had a lot of problems, but not least of which is that it was running on CentOS Linux 7, and that was going EOL. So we had to do something, and we worked through like, okay, we can move this content here, we can do this stuff with that, but we didn't get everything moved, and we just at some point had to discontinue the wiki. And so there's a wiki archive up. You can find an archive of all the information that was on there, but it's not anymore a primary source of information. And so now that it's gone, there was information that was the primary source of truth for. So what are all of our special interest groups? That was wiki.centos.org/special interest group. What are the events that we're putting on or that we're present at? Stuff like that. We no longer had a source of information for. So the new hotness was to find a new home for all of this information. So here's this is the new website, and you could see on it that we highlight CentOS Stream and CentOS Hyperscale right now, and we use that space there just to advertise CentOS Connect. I suppose I should probably take that banner down because I don't think anyone's flying to Brussels right now to join us. But and then below that we have a list of our special interest groups, and it's cut off at 3 for the screenshot. But if you scroll down, you see I think 3 more, and then a link to a button that shows you all of them. Actually, I have a screenshot of that a little bit later. And this is our new doc site. It's not quite as themed. It's MK docs, but it's very usable. And you can see that we have it's highlighted on right now the quick docs section, but the CentOS stream docs are there, and then all of our various SIG stuff, our infra and our various other SIGs is all listed on a single doc site. So we did it. This is the part where I do the we did it and sort of. And this one, actually, I don't have a sort of on this. We launched this new website, and the new design came from Elaine, who runs our artwork SIG. And so huge kudos to Elaine and to Fabian, who does all of our infra, because I know Fabian was working when it was already evening for me, and he's in Europe, so it was a lot later for him. Both of them were putting in some kind of crazy work to help us get this stuff done. And thanks everybody who's been at like the doc days and has participated in this, because it was really a team effort. So we did do it. I'm not doing a sort of on that. Now, sort of. We did it. Our new website showcases the SIGs on there and some different additions. Except some of it's kind of buried. It's still like where the container image is, or the new image-based stuff like with boot C. If you're interested in that, where would you go to get that? It's all there, but we don't highlight it right there on the front as different kind of additions that you can download. Or the alt images stuff that Troy will talk to you about tomorrow. You know, we have the live images from the alt images. Oh, by the way, we have, if you need to run a live image, we have USB keys with the live images that Troy Sig just produced. So, a few of the other things now we could highlight a little bit better, but we at least kind of now have the framework that we can start plugging that stuff into to showcase the work other than CentOS Stream that happens within the project. We completely rewrote the About page, which again had a whole lot of information in there about CentOS Linux and about, it was a really good About page for the CentOS project 6 years ago. We created a new contribute page. So one of the things I mentioned on the wiki, there was wiki.centos.org/contribute, I think. And that's where we always pointed to people to. That information was pretty outdated, and also it was on the wiki. So we have a new page just on centos.org right now. And for further information, it links off. We have contributor information in the stream docs that you saw on the doc site. But we have kind of a single page now that has just high-level information about how to contribute. These are pretty good, actually. But we need to keep them current. Things like this can easily go out of date, and people like, oh, we did it, hooray, we're done, you know. And we can always use more eyeballs looking at the contribution docs and the stream docs. A lot of times for people who are regularly contributing, it's not always easy to realize when the docs are missing some piece of information, right? You know something, and you don't. It just doesn't occur to you that somebody else might not know this. So if you look at the docs and you say, I don't understand what I'm supposed to do at this point, give us that information and we can use that to improve it. We have a new SIGs page. So instead of the old wiki page for the SIGs, we have centos.org/SIGs, and it has a list of all of our active special interest groups. And they all have links to various things. Some of them have a landing page. Some of them have documentation, links to the repository and stuff. Actually, I think I have a screenshot. Yes, I do. So this is some of them: Automotive Cloud, Docs, Hyperscale. And you can see a few of them have the information button. They have a landing page right there on centos.org. Otherwise, there's also links off to the documentation or other things. So we did it, but not all of the SIGs have a landing page. We'd like to make landing pages for at least most of them that give you just kind of a high-level overview. And also, a few of them don't have docs. In particular, you'll notice that the docs SIG does not have docs. I don't know. Does it? Yeah. That's. Hold up. What? Damn, we do. Wait, is there information in there though? Yeah, good job. Okay. So we need to fill in the docs for the docs sig. That's me. I'm the problem. It's me. But we have a listing of SIGs, and it's really useful to find. It's really easy to find information now about all of our SIGs, including like where their repositories are and where you can go file bugs against them. We launched a new doc site, as I already said a few times, with all of the docs all included in there. Oh, here's where I'm calling out the doc SIG, but some of our SIGs don't have docs, so we're going to work on that. We created a quick docs doc, basically, and we took this straight from Fedora. We like stealing things from Fedora. We created these quick docs, and it's a place where you can just drop very standalone how-tos. If you want to give instructions on how to do a specific thing, you don't have to worry about how it fits into some larger manual structure. You can just write a how-to, put it straight there in the quick docs, and it's an easy place for what would traditionally be kind of wiki content, right? These like standalone pages. We didn't actually write all the how-tos, or really much of any of them that we wanted to. But we did make issues, so there's a link there that I'm sure you're all frantically typing in right now. That has some issues we filed, like these are some things that we would like to write some how-tos on. So we at least have that so people know places where they can contribute. And also because we have a place to put the issues now, like if there are things that you want, something that you think there should be some how-to, some quick doc on, you can just go in there and just file something, and that lets us know what information people are missing. So that's a good place to just ask for docs. And if we, maybe you put something in there and we're like, oh, maybe that should actually be here in the stream docs or somewhere else, that's cool. We'll figure it out. That's a good place to just drop an issue. So I think that's all of my we did it's. Yeah, so what now? We have a docs SIG that's doing stuff. And you can see our emails on there, CentOS docs at centos.org. There's a matrix channel, the CentOS docs on fedora.im, FastID. We will have a CentOS doc day here in Brussels after FOSDEM. We've been having these pretty regularly. I think the last 2 years at FOSDEM we've done a doc day, and we did one last year at Flock. These have been really useful for us. We get a lot of the people in a room together, and we really kind of hammer through a lot of these issues, make a lot of progress. So we're going to have one here in Brussels. It'll be on Monday, the day after FOSDEM, and it's going to be hosted at the Meta office here in Brussels, so thanks to Meta for hosting us. If you are sticking around in Brussels and you want to work on docs, you're welcome to join. But talk to one of us, because I think you have to fill out a form or something to get into the Meta office. So I'll direct you to our Meta people. Other than that, we'll continue our work mostly on Matrix. I'll be honest, like most of us do not use the mailing list very much, and we kind of just chat and use issues and stuff to keep track of stuff. But you are welcome to use the mailing list if you want to get in contact with us. But we have our doc day where we'll work through some of these issues. And continue trying to make the web and the docs better. So any questions? Yeah, I should be my own mic runner.
Yeah, you mentioned that some of the content is buried, but is it searchable with the top search?
It is searchable.
Well, it's already way better then.
Yeah, it's searchable. One of my like minor complaints that I'd kind of like to look into is with MKDocs. The way it's set up right now, when you search, you're searching across all of the published docs, and I think if there's times where it'd be useful, like if you're on the hyperscale docs that you want to search just within that particular document, which is not how it currently works. It'd be something to look into, but there is search on the site, so that's good. Any more questions?
So you talked a lot about CentOS SIG spectral documentation and your quick docs and stuff. So what about the documentation for core CentOS Stream, i.e. the Red Hat Enterprise Linux documentation? How does that fit into this picture? Yes, I know I hurt you with this, but it needed to be asked.
Okay. So there is a whole lot of documentation for RHEL that is kind of usage documentation. So the documentation we have is not so much usage. It's not an install guide. It's not an administrator guide, right? It's not that. It's about the project really, and not about the operating system. The documentation that exists for RHEL is publicly developed, and we are able to adapt it and turn it into CentOS documentation. It's in ASCII doc, and it uses like these conditionals and substitutions that we can actually use to turn it into CentOS documentation. We would probably have to publish it separately because it's not going to go into the MKDocs workflow. If anybody is really, really interested in that, it's there, but it's been there. I've had talks with the RHEL docs people many times before, and it's always been a matter of we need to step up on the community side to do the adaptation. And I've so far failed to get a lot of people to do that. If that's your thing and you love doing ASCII doc conditional work, come talk to me.
So they actually made us a fork. I met with them in Brno almost 2 years ago now. So we have a fork of their docs. They're like thrilled if we want to make new things like a quick start. So they really want us to work on them. So as Sean said, if someone's sticking around on Monday and would like to work on this, or if you don't want to stick around on Monday and work on it, but you still want to work on it, let us know.
Just thinking out loud here, do you think it's possible to have engagement from someone from the RHEL doc team to just work upstream? Like I have that specific corner case in mind when CentOS Stream 10 was already available, in fact, published to the mirror in June, but there was nothing, like no documentation about how to install what was new, no release note. Even if that was work in progress, would it have been good to have someone from upstream just to start working for themselves, the documentation, and to have something before? Do you think it's possible to engage with them?
I want to not throw anyone under the bus here because I've worked as a technical writer, and I understand the difficulties of deadlines and deliverables. Technical writers are nearly always understaffed for the deliverables and the deadlines that they have, and they are very happy to work with us, but unless the management well above them decides to give them more staffing to have somebody who's really devoted to upstream, they're just not going to be able to spend a lot of time on it because they have to deliver docs for the products so that, you know, Red Hat's customers are happy and whatever. So I think that's the reality of it. Thanks.
Yes, but especially if they are under pressure, starting to work on that before, because that's work that needs to be done for them, for RHEL, even for the RHEL beta, there is a need for have some kind of documentation about the release note about what's new in RHEL 10 beta. So if you start doing that directly on CentOS Stream while the product is being worked on, I mean, not the product, but the first deliverable for CentOS Stream 10 is done, and they have conditional done directly from day one, nobody has to reverse engineering the documentation to make it CentOS compatible downstream because it will be work done directly upstream. No? I'm just trying to push the wheel forward, in fact.
Maybe. Yeah. It's a conversation that has to happen with them, I think. So.
On this point, I would say a lot of, last time I looked at the RHEL docs, a lot of the work to do is dealing with conditionals to where they talk about RHEL specifically and changing it so that it talks about CentOS. This is an area where I think there's room for collaboration also with the rebuilders, because it doesn't have to be CentOS, it could be dollar distribution, and because these are generic EL docs, they're broadly applicable to CentOS, to RHEL, to Alma, to Rocky, to Oracle, to whoever. So I think this is an area where there could be good opportunities for collaboration there as well.
I agree. And it's so, I've been inside of them some, and so some of it's really easy, like it's already marked, you know, like $ product name, and you just change that to CentOS stream or whatever. That's super easy. But some of it is you need to read through it and figure out where they're talking about, where they mention subscription manager, and they go, oh, well, that's not something we do, you know. So like you have to read through and look for those kinds of instances, and that's the harder work to do. And that's something we all share because none of us have subscription manager, correct? Correct. Yeah. All right.
It's in the repos.
Any more questions? Okay. Thanks, everybody. So we have our next talk will be Dennis Gilmore talking about OKD and Kubernetes on CentOS Stream, and that's at 4 o'clock actually. So you have a 38-minute break. All right, hi everybody. Hi, hello. Oh, I pressed mute on the soundboard before the break so that you didn't all live stream your personal conversations. Hi everybody, there we go. Welcome back to our last block of sessions. We'll have 4 25-minute sessions here until the close, before the close of the day. So we'll just get right into it. Introduce Dennis Gilmore, who will talk to us about OKD and Kubernetes on CentOS Stream. So please help me welcome Dennis.
G'day everyone. So I'm an engineering manager at Red Hat that is responsible for the systems enablement team. We enable OpenShift on vSphere and IBM P&Z. Excuse me, wrong time. You know, some of the public cloud stuff, IBM Cloud, Nutanix, all the different platforms. And one of the other teams I have is OKD, and I'm here to talk to you all about that. So quick agenda. I've got a few things I want to go through. OKD and CentOS, and the relationship, the value proposition of OKD, the benefits and the opportunities that are there, the target users for OKD, which is not a authoritative list or the only target users, the workflow of OKD, and some of our plans in the upcoming future. So let me just make this a bit bigger so I can see it better. All right, so OKD is aiming to be a fast-moving Kubernetes distribution, though we're currently a little bit slower than we would like to be. We did, thanks to the community, we were able to release 4.16 and 4.17 at the same time in December. And they were the first releases that were entirely built on top of CentOS Stream content. Prior to the 4.16 and 4.17 release, the containers were all rail-based and were essentially the same content as OpenShift. And we went through a process last year where we had to shut down building and shipping OKD, and we moved to building everything entirely on top of CentOS Stream. So it was kind of a big move. And then the core OS that's used in OKD historically, most people used Fedora core OS, and we're using CentOS Stream-based core OS for everything going forward. We've left the door open that we could do a Fedora core OS again, or the community could do a Fedora core OS. We don't want to say never, absolutely not, but the main focus that we're working on to ensure that we're somewhat focused in what we're doing and get the most value, and in our pivot towards making OpenShift, making OKD be the upstream of OpenShift, we want to focus on CentOS Stream, as it's much closer to what OpenShift runs on and gives us a signal for things in OpenShift, like when file version bumps. One of the goals that we have is to share tooling and processes as much as possible. Primarily with OpenShift, we don't want to go through a process where we use different build systems and different release tooling and stuff like that. We want to do it the same, but at the same time, we also want to engage in the CentOS community and use the same tooling and processes there. There is some RPMs that we bring into OKD, and they're all built in CBS as part of the Cloud SIG and the built-in tags there. And we want to make sure that it's usable for people, so we've got some people in the community that are working on an operator bundle, thanks to Zed in the back there, where we have KubeVirt and things available to run on top of OKD. So at the moment, OKD is largely a consumer of CentOS Stream, and as we build an OKD community, I want to ensure that we are good CentOS citizens and giving back as we can, and I could certainly use the help, or we can use the help from the CentOS community to tell us ways that we can engage in CentOS better. So OKD, the value proposition as I see it and as I've kind of pitched it to the people inside of Red Hat that I needed to get approval from to invest in OKD and make it be a viable thing, is as follows. OKD builds and the containers, everything CentOS Stream. That is, in part, as I said before, to increase, to detect when things break and get an early signal, but it also gives us a way to enable people to contribute from external. So ideally, everyone should be able to contribute and participate in OKD. We also want to make sure that we don't distribute any rel content as part of OKD, which is another factor. There was a discussion as we change things whether we base most of the containers on UBI, because UBI content is free, but there is some content that goes into OpenShift and OKD that comes outside of the content that is in UBI. And for simplicity's sake, we opted to move everything to CentOS Stream. We want to make sure that everyone can contribute, and if you got parts of it that are behind a paywall or behind a Red Hat wall, it doesn't make much sense. The VCSP is a verified cloud service provider, and I think this is an area where potentially there is a lot of opportunity for people. It is targeted largely at smaller clouds, where the cloud provider does the install of OpenShift, and they run the OPCT, which is a certification tool, and it validates that this meets OpenShift criteria, and they then they show us and prove to us that it runs properly, and we say yes, you can call it a supported OpenShift. Ideally, in my mind, that work happens before it ever becomes part. Before it doesn't happen in OpenShift. It happens like in OKD, and like anyone that wants to add, whether it be a cloud provider or if someone comes up with a new virtualization stack or whatever, if they're wanting to make OpenShift run on their product, they would do that in OKD, prove that it works, prove the value of it, and then it gets merged into the product and becomes a thing. But it's possibly not a big thing for the CentOS community, but I think it's a way that it adds value to OKD and enables people to experiment and do things. Ideally, I'd also like to have OKD just people be able to do things that we don't necessarily want to, like if you're a Red Hat person working on OpenShift and you're like, I hate the scheduler, I don't, just to follow on from Alessandro, like if you don't like the scheduler, you want to redo it, you should be able to experiment like you can with CentOS with the SIGs and stuff like that. You should be able to experiment, throw out the scheduler, write your own scheduler, put it in, and then go to the, come and say, hey, look, this scheduler works 100% better, it's less overhead, and things get scheduled in half the time on whatever it is. There should be a playground in OKD where you can experiment and try different things. And then the other big value proposition that I think that we can get with OKD is just the continual adoption of Kubernetes. So if you look at, Kubernetes releases 3 times a year today. They changed from 4 to 3 a while ago. They release 3 times a year, so about every 4 months. And every time there's a Kubernetes release, Red Hat rebases that, and it takes a lot of time and effort. Ideally, what I would like to see is a way that we can, as things are going into Kubernetes upstream, we're pulling them into OKD and integrating it and testing it as the development is going, and that way, ideally we would release the OKD release much sooner than, others, and, pick up the new versions of Kubernetes, quicker. I think today OpenShift releases 12 or 16 weeks or something like that after, it's about 3 or 4 months after a Kubernetes release, OpenShift releases on top of that, and I would like, OKD to be releasing, like 3 or 4 weeks after the Kubernetes release, and, having, an OKD release on that out sooner. And I think that that adds a lot of value for, Kubernetes to an extent, certainly for Red Hat, and certainly for like CentOS and stuff where you can try, latest and greatest things sooner than, you would today. There's a few benefits and opportunities. Some of the big opportunities is allowing external contributions. That has things that we need. There's currently no contributor guidelines, so like the Fedora packaging guidelines and CentOS packaging guidelines, we don't have defined mechanisms like I want to build, there's, say KubeVirt. I want to make sure KubeVirt's available to run on OKD. We don't have a mechanism today for, someone to say, how do I package that up? How should I ensure that it works, integrate it, get it in. So, that is something that we need, and something we need to work on is just defining contributor guidelines, lots of documentation, and all the different parts that go into it to make a community. Because right now, OKD is. There is a small community that's very passionate, and given the resources that have been allocated to it, it has delivered a lot, but it has got a lot of potential and a lot of room for growth. Ideally, I'd like to have it give us much better flexibility, like this scheduler thing I talked about. Like, you should be able to throw anything out, or if you want to get rid of the console or replace the console, you should be able to do that. And to date, there's not really an easy way to completely wholesale replace something in OpenShift, because you need to ensure continuality, and I think OKD offers that opportunity to enable people to experiment and do the things that they may want to do. So we do have a set of target users that we've been, at least I've defined as, these are the core places that we'd like to go after. One of them is developers who write applications that run on Kubernetes. It could be that in your day job you write applications that live on top of OpenShift, and you like writing code for fun, and you want to do some hobby projects or something like that at home. OKD should be a place where you like, that's where I want to be. It's similar to OpenShift, but it is not OpenShift, and allows you to do that. Students that are developing, and it was pointed out to me earlier that also researchers, like people that are in academia, don't have money, but they're wanting to learn how to develop applications. They want to learn how to, maybe it's a sysadmin that just wants to learn, like, how do I run Kubernetes? How do I run a cluster? OKD should be an ideal target for them, whether it be a single node use case or multi-node cluster, or different types of environments where you can develop or run things in any kind of environment. Self-sufficient technologists, so that's smaller businesses that, or an example that I have of that is like CERN, who use a lot of open source stuff. They have a lot of sysadmins. The money that they get, they would rather not pay for software. They want to support themselves. They are comfortable supporting themselves, they're comfortable digging into code, fixing bugs, or they're comfortable reaching out to the community and saying, hey, I'm doing this thing and it's broken, but they're willing to dig in and they don't want to have someone that they call up and say, hey, your thing's not working, fix it. They're very much a target user, I think, for OKD. Red Hat partners that want to work on support, so like Oracle Cloud, we enabled in OpenShift recently. Oracle are doing all the work to support that. They're using OPCT and the tooling that we provide to validate everything. They should be doing that work first in OKD and engaging in the community side of things rather than putting it straight into the product. And then the other use case that I have, and this is not the extent, is internal teams inside of Red Hat that, like RDO use OKD to develop OpenStack, and they should also be target users for OKD. So the workflow of how things get in, and I think it's somewhat critical in that I want to ensure that people don't bypass like CentOS or Kubernetes in getting things into OKD and just trying to put things straight into OKD. The feature development should go as upstream as possible. So if it's a change in core Kubernetes, you shouldn't do that in OKD, you should do that in Kubernetes. If it's a change in the underlying operating system, that should go into CentOS Stream first. It shouldn't go into some RPM that we shouldn't be forking RPMs and putting them into our builds just because we want to change something and we want to bypass the process. It should go as upstream, all the work should go as upstream as possible so that it benefits everyone, not just the OKD users and community. The work that goes directly into OKD should be things like the console and things that are part of OpenShift that only exist inside of OpenShift. They're not, they're living on top of Kubernetes, they're not inside of Kubernetes. Those types of things should be developed inside of OKD. And then that flows into the product. At least that's how I feel, and that's the way that I'm trying to push things so that we engage in the communities and are good citizens and not just taking advantage and not giving back. So in the shorter term, we've got some plans. Right now, OKD, as I said, we had 4.16, 4.17 releases in December. They're installable in some use cases, but unfortunately, due to weird reasons, like bare metal is not easily installable today. And one of the things we need for that is to actually push out some CentOS Stream-based boot images. And so I've been working with Fabian today on how we can get them. There's builds, the CoreOS team has taken on building CoreOS and delivering CoreOS based on CentOS Stream specifically for OKD. But we need to get that, they're building that in the internal Red Hat pipeline, and we need to get those builds published out so that we can consume them in OKD. Getting the text is really small in front of me here, and I couldn't read it. Getting, just laying a foundation for a community, because OKD historically was the output of the OpenShift build process, and it was kind of a byproduct that happened to come out, and we pushed it out and made it available. And so I'm trying to set up a community around OKD and build. I'm getting a small team to help manage the build and release process, but they're going to be targeted with doing the community, but it is a new effort and it's coming along slowly. In the medium term, we want to get things like managing updates properly. At the moment, we use a release controller that creates the update graphs, and there's some limitations in that. there's some infrastructure changes that we need to make around how we do OKD that needs to be, better. There's a lot of things that need to be better and a lot of things that need to be built up, but it is slowly getting there. And ideally, I'd like to support multi-arch. I'm a big believer in it. My laptop is ARM. All my machines I use at home are all ARM. And currently, OKD is x86 only due to some limitations in PRAL, the system that is used to build all of the containers. And want to get away from that and at least support ARM, if not Power and Z as well. And ultimately, in the long term, we want OKD to be a good Kubernetes citizen and be a certified Kubernetes distribution. To date, OKD has never been submitted upstream into Kubernetes to be considered a Kubernetes compliant thing. And we want to be part of that community and be good citizens there. And we want to integrate community built operators and make things better for kind of everyone. So it's a rough timeline, a rough roadmap of like when we want to, and this isn't purely from my viewpoint because I've not gotten buy-in from the community yet, and but it's what we're working towards. So, questions? Things that you think we could do better, or things CentOS would like to see from, a Kubernetes that runs on top of CentOS. OKD? In theory, OKD, so the question was, what does it stand for? In theory, I believe it doesn't actually stand for anything. Most people say it's it's kind of a recursive. The KD is Kubernetes distribution. What the O stands for, it's not entirely clear to me. Maybe Amy knows or someone else knows. Yeah. So OpenShift 3, like the open upstream version of OpenShift 3 was Origin, and I think largely the O is just O.
So this isn't a question, this is just thank you. Sorry, wow, I didn't expect to get emotional from that. Thank you for taking it from RHEL to CentOS Stream and making it CentOS Stream based. Thank you. That's all I wanted to say.
Any more?
Thanks, everyone. I appreciate it.
Thank you, Dennis. I once again forgot to start my timer, but yeah.
Right on time.
You perfectly on, yeah. you're ready, we can start early. Oh, we can wait? Or, yeah. I don't know. I think the room configuration is not going to change. So, hi, we'll welcome our next speaker here, Joel Capitao. Will talk to us about from RPM to S2I for an OpenStack service in Complex. So please help me welcome Joel.
So during the CFP, I thought it could be interesting to share to you what we are working on at RDO currently. So for those who don't know, RDO is a RPM-based distribution of OpenStack. So we basically deliver a set of RPMs to be able to install OpenStack on a CentOS Stream system and also CentOS-alike systems. So, and now we would like to experiment a new way of distributing OpenStack through container images. And while building those container images, we want to build the OpenStack directly from the sources instead of using RPMs. So yeah, in that talk, I will present you what we have achieved so far. And yeah, on all of that on Conflux. That's the new build system we want to experiment. So first, what is source to image? It's basically a framework for building container images from source. As it's also a framework, it's also a standard that provides standardized ways to build container images, making the process more efficient. And on top of that, you need some scripts, some source to image scripts. It's basically executables that helps you to assemble, to build, test, and ship your application. And source to image, it's a core component of the OpenShift ecosystem. So now, how we have implemented source to image into our experimentation. So we have basically two stages. The first stage, it's the build stage. So you have a builder container image. On top of that, you pull all the sources, okay? And then with some shell scripts, you build all of that, and you have some artifacts at the end. So that's the build stage. In the second stage, which is also the final stage, you have the runtime container image, and on top of that, you pull the artifacts that you have generated in the first stage, and you end up with a source to image container image. So in our case, the shell scripts, it's just commands. I mean, just shell commands. It's not bash scripts or and so on. So now, why RDO is experimenting source to image? To understand that question, we need to look backward a little bit. So I don't know if you remember, last year, my colleagues, my colleagues that are also working on RDO, it was Carolina Kula and Alfredo Moralejo Alonso. They presented you the OpenStack Kubernetes operators. So it's basically a deployment tool that helps you to deploy an OpenStack on CentOS Stream system. And it's also the successor of TripleO. TripleO was retired a couple of years ago, and this OpenStack Kubernetes operators is the direct successor. Actually, that's the same contributor that are working on this project. So this project is based on operators. So Kubernetes operators extends the OpenShift functionality to automate the deployment and the management and operation of your application. And it's written in Golang. So yeah, I put that picture just to give you a brief overview of how it's working, but I won't go too much into the details. So you have in the gray part, you have all the stuff running on OKD. So you have a bunch of operators. So this is the control plane meta operator, which deploys an operator for each container service, for each OpenStack services, okay? Then in the right part, you have the data plane operator, which drives the external data plane, which is running outside of the OpenShift. And on the upper part of the image, you have the operator images that are pulled by the OpenStack operators, and you have on the upper part in the left, you have the OpenStack container images. So if you want to understand better that picture, I recommend you to watch the record of the talk of my colleagues that took place last year. And also I put a link to the page which is hosted in the CloudSig documentation that explains all of that more in detail. But in our case, so last year this was just a proof of concept. And this year, we want to go a step further. So you can see that the OpenStack container images, you have the TCIB builder. So TCIB stands for the container image builder. So it generates a set of container files, okay? And those container files pull the RDO packages, the RDO RPMs, to create the container images. And now, what we want to achieve is to deliver directly those container images by creating this container file and by generating the OpenStack bits directly from the source, okay? Also, RDO will deliver those container image. That's what we are experimenting to. So does that mean that it's the end of the RPMs? Absolutely not. What we want to achieve is that everything that is related to OpenStack, we want to build from source. But what the other services, like the Apache or the Open vSwitch or the RabbitMQ, we want to install those services from RPM, okay? So everything that is under the OpenStack governance, so all the project, which is mainly Python project, we want to build the wheels, the Python wheels, and to install those Python wheels. So we will have the best of two worlds, so the RPMs, and the Python wheels from source. So now you might be wondering, why now? Why are we experimenting source to image now? Because it's not new at all. I mean, there is plenty of deployment tools out there that already distribute OpenStacks through container images and from source also. The main reason is Conflux platform. It might be a little bit scary at the beginning, but you might know already there is a strong push in the Fedora community about this Conflux platform. And at RDO, we want to tackle down directly by experimenting it. So yeah, we thought it was the right time to modernize our workflow, let's say, because RDO is like more than 10 years old now. So yeah, we thought it was the right time to experiment a new workflow. So a few words about Conflux platform. So it's an open source cloud native software factory focused on software supply chain security. So some key features. It complies to the SLSA level 3. So SLSA, it's a security framework which consists of a checklist of control to prevent tampering. And there is also other stuff like more integrity and so on. It includes a bunch of automated security checks, and also it enables hermetic builds. Some benefits: you have more security, better reproducibility, and there is an increase of efficiency. So Now that we have some context on why we are experimenting source to image and why now, let's dive into the code base we have so far. So remember, Conflux enables hermetic builds. So in order to build your container images, you need to prefetch all the dependencies first, the same way Koji does. So when you are building your RPM, you need to have all the dependencies in the build root first. So that's the same thing here in Conflux. To do that, Conflux is using Catchy2 behind the scene. Catchy2 supports the main package managers. So for Golang, Python, Node.js, and DNF. Still, DNF is not officially supported, but it's in development. It's work in progress. But you can already enable this feature by enabling a flag in your Conflux configuration. So Catchy2, it takes as an input a list of your dependencies, and it downloads those dependencies from the URLs. And to do that, for the RPMs, there is a project which is RPM log5 prototype. So this project takes as an input a list of packages you want, and also it takes as an input the repository from which you want to pull those packages, okay? And RPM log5 prototype, which use libdnf behind the scene, it will resolve all the dependencies, and it will generate this log YAML file as an output. So yeah, you can see that there is the URL on some metadata for all the packages that were resolved by libdnf. Now we need to do the same thing, but for the Python modules. So it's the same story, but instead we are using the pip compile CLI tool from the pip tools project. So it takes the list of modules you want, okay? So in the requirements.in, and it generates the requirements.txt. So it's using pip resolver behind the scene. So here you can see that in the upper part of the slide, you can see the command we are using. So we are putting some constraint with the upper constraint.txt, which is the constraint coming from the upstream OpenStack project. We ask pip compile to generate the hashes, and it will generate the output file requirement.txt. So you have the requirements.in, the 6th first line of the file, and you have the result at the end. So you have the different modules with the right version, and also the hashes. And also there is the constraint information to understand better why you are pulling those modules. So now that we have all the dependencies, we can start building the container image. So as I said before, the first container image we need is the builder one. So that's the container file of the builder we are using. So basically, it's based on the CentOS Stream 10 image. We are importing all the RPM GPG key to verify the integrity and authenticity of the packages. And we are basically installing all the packages we need. So yeah, it's mostly development libraries, some compilers for C, C++, also Rust. Once we have this builder container image, we can focus on the OpenStack images. So for that, for those images, I'm reusing the what TICIB have done so far. So there is this OpenStack keystone on every OpenStack services. They are all dependent on the OpenStack dependencies. These container images includes all the OpenStack clients. Okay, and this OpenStack, this container image is based on the OpenStack base, and this OpenStack base contains all of helper scripts needed required for all the OpenStack container images. So instead of installing every time the OpenStack clients in every containers, we are just installing them in one container, and then we are basing the other container based on this one. So let's first focus on the OpenStack dependencies container image. I mean, the OpenStack base is not really interesting. It's just helper scripts. Whereas in the OpenStack dependencies, we are installing the OpenStack client, so it's more interesting. That's the container file of OpenStack dependency container image. So as you can see, there is 2 steps. So from line 1 to line 36, that's the build stage, okay? And from line 38 to 41, so the last 4 lines, that's the second stage, the final stage, okay? Let's focus to the build stage. So we are basing this stage on the builder container image we have built previously, okay? We are creating the virtual env. So you might be wondering why we are creating a virtual env. It's because we want to force Python or pip to install all the artifacts into one directory. And if we don't do that, it will install all the artifacts across the file system, and then it's much complicated to get those artifacts. So by using the virtual env, we are installing all in one directory. Then it will be more easy to copy paste this directory to the final stage. So that's why we are using virtual env. Then from line 5 to line 20, we are generating the wheels. So just before executing the pip wheel command, Conflux will export the pip findings on the pip index environment variable. So that tells pip to not look into to the remote PyPy index, but to look into the catchy2 output folder where we have stored all the dependencies prefetched just before. So in that command, the pip wheel will generate all the wheels from the source distribution that we have prefetched with catchy2 before. And then from line 22 to 36, we are installing those wheels into the virtual env. Okay, so that's the build stage. And then in the final stage, we are just pulling the OpenStack-based container image, and we are copying the virtual env. So you end up with all the OpenStack clients into that container file. Just for comparison with what we have in TCIB, so that's the current container file generated by TCIB using the RPMs. So it's basically the same, but we are using the RPMs there. So it's more simple, but you need to build the RPMs first in that case. Whereas in the source to image, we are doing all in the same place. So building the source and creating the container image. And then we can take a look at the Keystone container image. So for those who don't know, Keystone is the identity component in OpenStack. So in that case, you have the 2 stages, okay? From line 1 to 17, you have the build stage, and from line 19 to the end, you have the final stage. So in the build stage, we are doing the same. So we are creating a virtual env. Then we are creating we are building the wheels. So you can see that the OpenStack Keystone/Keystone, it's a submodule that we have cloned before. And then from line 13 to 18, we are installing the wheels into the virtual env. And you can see in the line 19, we are importing the OpenStack dependencies container image that we have generated just before. And we are copying the same way the virtual env. And also we are installing some RPMs. So yeah, some HTTPD modules for authentication, and yeah, and so on. So yeah. Yeah, I just wanted to show you the UI of the Conflux. So from left to right. So you have the init task, then the clone repositories, where we are cloning the main repo on the submodules. Then we have the prefetch dependencies task which is using cache2 behind the scene to fetch all the dependencies. And you have the build container task, which actually build the container files. And then you have a bunch of security checks. To be honest, I'm not paying attention to that security check. I don't know why it's yellow, to be honest. But yeah, just you to have a brief overview on how it's working. So what's next? First, we would like to standardize, so to create a workflow to migrate the spec files to the container images. That's the first thing. Secondly, we need to fix some limitations we are hitting currently. One of the limitations is the when you want to build the bcrypt module. So it's a module that helps to create some hash of your password before storing to the database. But in the last major version of bcrypt, it's using the Rust compiler and also the C compiler. But the problem is that cache2 is not supporting the crates. So you need to look at the crates remotely on the Ethernet. So that's the first limitation we hit. We can bypass that limitation by using the generic driver proposed by cache2, but yeah, we need to work on that. And then, lastly, we need to study the corner cases. For instance, how to patch your code. I mean, with RPM, it's very simple. During the prep section in your spec file, you can apply some patches. You can do some set comments to modify the code base. But in that case, you cannot. One of the solutions is to fork the upstream repository and to point cache2 to that new to that fork repository. But there is also other corner case with that solution. And that's it. So thank you for listening. You can find the code base on my GitHub following this. If you want, if you have a question, feel free.
I probably have multiple questions even if I'm not using OpenStack anymore. But I remember how the pain it was to just have Horizon, Keystone, Nova, Neutron working together as RPM package. If you build container image, so far I've seen that the workflow seems to be clearly Kubernetes, operator, and so OpenShift. Is there a way to just use container image like to bootstrap from Podman some pods to have minimal OpenStack services running from container? Because if you can orchestrate that, that is possible, I guess, or that's not possible so far. I mean, the question is, do you just target OpenShift-based deployment?
I think you need OnOKD to be running that. It's not possible to run on Podman. We should try on Microshift. We haven't yet tried on Microshift. But yeah, for now, you need an OKD platform to deploy on OpenStack, which require a lot of resources, I know, but yeah. We should try on Microshift, but we haven't yet tested it.
Okay, thanks a lot. Second question, if I can. Thanks a lot for the presentation, because it seems that in the last 10 minutes, I learned much more about OpenConflux than in all the vaporware things I heard in the last 2 months. So thanks a lot for this. Just asking, because of course I know that in the past, RDO was building on top of Koji for special interest group. Now it seems that you build elsewhere. So does that mean that the cloud SIG will suddenly move away from CentOS building infra? Or because the question is, where are you building that? Because Conflux is nowhere to be seen publicly yet. So
we are still building RPMs with the Cloud SIG, but for everything that we cannot package with Conflux, okay? And to be clear, we want to, in addition of the RPMs, we want to deliver a new way to distribute OpenStack, but we won't stop building the RPMs. So we will still build the RPMs, and in parallel, we will deliver those container files and container images.
Okay, so directly straight from a Conflux instance running somewhere, we push that to registry, I guess, that people can consume.
It
Okay.
will be on Quay.io. I'm using the Fedora cluster in that.
Oh, okay.
yeah.
Now I know. Okay.
Yeah.
Thanks. Good. Good to know.
Because there is no Conflux cluster on for CentOS Stream.
No, there is none, and that's a discussion for later.
Yeah.
But, yeah. And the last thing, which is just like more kind of a joke, sorry for that. Assuming that you are going away from RPM distribution and RDO was the RPM distribution of OpenStack, will you change the name to C, like container distribution of OpenStack, or CRDO, like container and RPM distribution of OpenStack? Sorry.
I think Amy won't be happy.
Maybe it's going too much into detail, but you mentioned it not possible to run it in Podman. What's the reason you can't run it in Podman?
It's a question of resources. So you need to have Kubernetes underneath to orchestrate all the container images, well, the operators, and you need to have a lot of resources, and Podman cannot do that. Maybe in the future,
Okay,
is the Podman desktop, but
so more like service dependencies that you don't have with just Podman.
sorry?
More like service dependencies you are missing with just Podman.
To be honest, I haven't tried. Yeah, I should try. That's a good question.
Any more questions? Thank you. We're continuously running just a little bit ahead of time. Does anybody have good jokes or a banjo to play? Bring it. I'm sorry, next time I'll bring something. So I think we'll just go ahead and get started. We're about 5 minutes ahead of time, and so if you want to go 5 minutes over your plan, then you can do that. So Andrew Lakoshko is the AlmaLinux OS lead architect, and he'll be talking to us about AlmaLinux, of course. So please help me welcome Andrew.
So today we're going to talk about AlmaLinux and specifically what makes it special, because you may think, oh, it's about some just rel clone. So it should be boring to do that. Trust me, it's not. So 2 words about myself. So my name is Andrew. So I use Linux for like, I don't know, for many years, since I was 16 probably. And the last 13 years, I work closely with Red Hat sources, doing something with them, some products out of them. And one of the products, like, and I currently work on AlmaLinux OS, and I'm lead architect from the very beginning. So if you hate something about AlmaLinux, I'm the right person to ask why it is like it is. So, in 2 days, we will celebrate our first public release. It was 4 years ago, and it's AlmaLinux 8.3 beta. It was very beginning, no features, no fancy things, just one architecture. We made a lot since then, but still, even if it's like rel derivative, we do a lot of things differently. And today I'll share some insights how we do packages, builds, and releases, how we do images, how we produce security advisories, how we do SCAP profiles, how we add additional hardware support, how we extend virtualization support in AlmaLinux, and how we extend Red Hat lib tool, which is used to migrate to next Red Hat version, to the whole enterprise Linux ecosystem. So all starts with building packages for us. We don't use Koji, we don't use Conflux, we use like own build system. One of the reasons why, because we do packages builds for more than 10 years, so we kind of have own vision how to do that and how we comfortable to do that. So we have AlmaLinux build system for that, specifically released for that. And it is open source, obviously, contains of many like components. Here are the most like main components of it. So it's web server, it's front end, it's build node, sign node, and sign file. What's the difference? So sign node is used to sign RPM packages. Sign file is used if you need to just sign random file with GPG. So it may be like repmd.xml or like checksum file for cloud image or something like that. And it uses a lot of open source projects, of course, under the hood. And one of them is Pulp, which I'm very happy about, and I will share later why. We use it as repo storage. So, what can we do? So, we can build RPM packages using mock. Yes, we're special, but not so special, so we don't implement anything here. We can build DNF models with this build system. So we can release these RPM packages built to internal pulp repos and then export them to file system if we need to like, push it to our mirrors. We collect security advisories information from Red Hat, somehow like, modify it and then use it in different sources, targets. And we can create own advisories because sometimes we do CVE fixes too fast and we have to do like some advisory for them. We can create personal repos. They are corp-like and compatible from client side. And we can do all kinds of SBOM magic. It's a huge topic. We talked about a lot of these like before on different places, and it's also in CentOS Connect, by the way, 2 years ago, I think. So if you're interested in SBOM, you should just Google it. Why I'm so happy about Pulp? So we don't use Punji if we need to release some updates. So we use Pulp natively to just add our packages to repos. So here you can see a page. It's public, so anyone can check what we release, when we release, who did this. And so it allows you to check packages, like repos and so on, that were released. And the most interesting thing here. So when we release package, we already know where repos it should go to because we monitor ourselves, we monitor CentOS stream repos. So when we try to release package, it's automatically distributed against repos. So here you can see we have like source repo for source package. We have all the architectures for NUARC package. This particular package is multi-lib package, so we place it into both 32 bits and 64 bits. And other packages like to corresponding architectures. And here also you can see like upstream, devel, upstream debug info, and so on. So it's super easy for maintainers to release package. So how our pipeline looks like. So we build packages, we run basic tests right after build. So can we install and remove package? Can we check for broken symlinks and other stuff? Then we release these packages to pulp repos. Then we run compose tests. It's the same compose tests that CentOS Stream uses, and actually we contributed to it several pull requests last year. So use them against pulp repos. We export pulp repos to file system. Then we push these repos to our primary mirror. And from this primary mirror, we push to our rsync mirrors around the world. I think it's about 430 of them currently. Kind of. Yeah, so next topic. Images. We produce a lot of them and we don't use Kiwi anywhere. It's not something we don't want to use, it's just how we used to do that. So probably we can reconsider it in the future, but so far we don't use it. So let me just explain how we do every type of image here. So ISO images, obviously we use Punji, but we don't use Koji build systems. So, and currently Punji is pretty much tied to this build system. So we had to maintain our own version of Punji, which doesn't use Koji. So to build AlmaLinux from it, you need to have local mirror of the AlmaLinux packages you are trying to compose. But it's not a problem. Our configuration files are obviously also public, so they can be checked. And we provide a guide how to build AlmaLinux ISO images yourself if you wanted. Container images. So starting from here, we usually prefer to use GitHub Actions. So because it's super easy to, for us, it's super easy to contribute for people. So if GitHub Actions are fine for some image, we are happy to use it. So for container images, we have container images repo, and from GitHub Actions, we build packages for every architecture. We push them to Docker Hub, Quay.io, GitHub packages. And we also create pull requests for Docker Hub official library. So obviously, AlmaLinux has official images in Docker. And we're not worried about this, by the way, about vendor lock-in or something, because our own git.almalinux.org is based on Git.a, so we can switch to our instance. Git.a is GitHub Actions compatible. So for live images, I also built inside GitHub Actions. So we provide a necessary kickstart file. We provide GitHub Actions pipeline. So it uses AlmaLinux Vagrant boxes. Inside them, we can do whatever we want. And so we built for Intel, we built for ARM. With Live Media Creator tool, we upload ISO images and logs to Amazon S3 bucket. And then we notify everyone interested in our Mattermost chat channel, so they can help us with testing of them. Raspberry Pi images also built inside GitHub Actions, and a pretty weird way probably, because we first start Fedora Vagrant box on Intel, then we run AlmaLinux IRM container on it, and then we do whatever we want. Why we do that? Because Fedora has full QEMU stack, and we need this QEMU user static binary. It's not available to in AlmaLinux, so it's easier to do that, but if it's too special, so it's also possible to use alternative pipeline on self-hosted runner. But if we want to use GitHub Action Runner, we have to go this way. It's fine for us. And also we build images, we upload them to S3 bucket, and we notify our users that we have fresh build to test. Cloud Vagrant images. So we built a lot of them. So it's like OpenStack, OpenNebula, Azure, AWS, Oracle. We don't build GCP ourselves because Google do these themselves, thanks to them. And Vagrant boxes for plenty of virtualization types and architectures. We provide Vagrant boxes for Apple Silicon Macs to run on VMware Fusion, Parallels, and so on. It's not very good automated right now, so it's some kind of area to contribute. So currently we do OpenStack and OpenNebula images in Jenkins. And for others, we are working on automation this quarter, probably next quarter. So if you want to help us, so feel free to join this activity. Security advisories. So thanks to Red Hat, they are public. So this data about security advisories is provided in different ways. So it's like security data API, oval feed, which is deprecated already, but still available. New way is VEX documents and RSS feed. So it provides enough information for us. It provides IDs, descriptions, links, and package names, version, whatever. So thanks to this information, we are able to collect them into our nice UI that maintainers can use. So we have all these advisories here. We map these advisories to our build packages, thanks to like, version release and so on. We can review, we can modify title, we can modify description if we need to rebrand something like that. So this works for several years already, so I'm pretty happy with that. And recently, when we started to deviate a little bit, and sometimes we need to release CVE fix earlier than Red Hat does, we need to security advisories for that. So we implemented UI for that, so we can create random security advisory with like title we want, description we want, like links we want, and so on, and release it under our name. So we decided to use the following pattern. So it will be like year, alpha, year, then A, and 3 digits, because to make it clear that it's AlmaLinux specific advisory. And then, when we have all this information, we distribute it in different ways. So we distribute it to our Rata website, we distribute it to mailing lists, we RSS feed. JSON feed, it's kind of our own format we implemented, so some security scanners use it. Oval feed, and we are not going to deprecate it, by the way, so it will be available. Update info.xml, it's like inserted right into package and repo data and used by DNF. And OSV database, which is kind of Google things, pretty modern, and we also there. And here is our Rata website where you can check latest security updates, choose version, severity, you can find something there, so it's pretty useful. Something else related to security are SCAP profiles, which is a framework to do configuration, vulnerability check, patch checking, compliance, wherever. And I'm happy to say that we are currently merged upstream. So not many distributions are there. We recently merged. There is no version releases yet with our support, so it will be next version. But it's still pretty good. So it's for 9 version currently only, but still. And in RHEL and other like distributions, this data is packaged into SCAP security guide package. So let me talk about how we do that. Usually, CentOS, in this package, CentOS is considered as Red Hat derivative. So it reuses all the tasks, all the checks, whatever from Red Hat. But there are some problems. We need to differentiate them more. So even if you have CentOS, it will have a lot of Red Hat names everywhere. So even if you have CentOS, it will say that it's checking for Red Hat GPG key, for example, but it's not the Red Hat GPG key. And also, like boot, EFI, way is path is different in AlmaLinux, obviously, and other things. So we need to. It's not possible to fix this when you're derivative. Other things is that AlmaLinux already have official guides from CIS and PCI DSS. So why not to show that? So in our profiles, we can rename these profile names to match our names, our release dates, and so on. So they're specific to AlmaLinux, but still compatible, of course, with Red Hat. So if you are running checks on AlmaLinux, it will be exactly the same profiles, exactly the same amount of checks. They will work the same way. Patch is huge, huge patch, 20,000 lines, but it's worth it. Another thing to talk about is hardware support. So after CentOS 7 end of life, users started to migrate and upgrade to AlmaLinux 8, for example, and they noticed that a lot of their hardware doesn't work anymore. Even worse if it's like storage hardware or network hardware, so you can't even install your system anymore on such. There is a repo project that provides a lot of modules for such operating systems, but it's not easy to use it. Sometimes you need to use it as driver disks. It's very hard to use it if you try to upgrade with Elevate or something like that. So it's much easier if this support will be included right into operating systems. And now, when we decided to deviate a little bit, we can do that. So basically, we brought back support for more than 140 devices. All of them are storage devices and network devices. Here's a list of drivers affected. And why it's a repo project here? Because actually we do what they do in their repo. So for this list of drivers, they don't bring any code. They don't update any code. They don't build like something weird. So they just use the same driver code that is already in Red Hat kernel, just unlock some drivers inside of it. That's why we just merged this work into our distribution. So there are two types of patches to make it. Inside Red Hat kernel, there is maintained two lists of PCI IDs. So one of them is disabled PCI IDs and another is unmaintained. So first of all, we need to move all the disabled PCI IDs to unmaintained list to unblock them. So in this case, it will work. You will get notification about this in your kernel logs that this driver is not maintained, blah, 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 but it will work at least. There are also several per driver patches. So to unlock specific patch drivers, you need to patch specific code, bring back some PCI IDs, or maybe some conditions may be there. So we need these extra 6 patches. And this is actually available in any AlmaLinux release. It's AlmaLinux 8, AlmaLinux 9, future AlmaLinux 10. So yeah, we support more hardware, and users love it. So even if we are special enough and still maintain compatibility with Red Hat, we are happy about this, users happy about this, but what we need to do if we need to test more major changes and how to make community test them, generally speaking, how to make even more special. We have an answer for that. So last year in October, we introduced AlmaLinux Kitten operating system, which is it's not AlmaLinux stable, it's a different thing. It's like Red Hat and CentOS Stream, something like that. So AlmaLinux Kitten is based on CentOS Stream. It's rolling distribution. It doesn't have any minor versions, obviously, and supported for the same 5 years. It's used as foundation for AlmaLinux 10 beta. It's already released, and we basically reused 92% of packages directly to beta. So it was very easy release for us. And in the future, it will allow to get updates earlier for AlmaLinux 10 stable version as well. So there are some changes, major changes, in comparison to Red Hat Stream, CentOS Stream in it. So we compiled frame pointers enabled, just like latest version of Fedora, latest version of Ubuntu, and probably Red Hat 11 will be with them. But we already did this to improve profiling and debugging experience. We support secure boot here for Intel and ARM already. We decided to bring back SPICE protocol support because our users asked for that and why it's dropped. I don't know. So in Fedora it works. So we brought it back. Also we brought back KVM virtualization support to IBM Power platform. It was also dropped. More hardware supported, and we implemented also additional Intel V2 architecture option to support all the CPUs since like 2008 that are currently supported in AlmaLinux 9. So to do that, what we have to do? RPM supports these levels like V2, V3, V4 since version 4.19, which is like 1.5 years old or something like that. But the problem is that nothing else supported. So we have to patch about 20 packages right now to make it work, especially like DNF, libDNF, and so on, libsolv or xpsign. Patched a lot. So we don't have time to discuss all of them. So we have a page with modified packages where you can check all these like list, commits, and so on. And what a surprise, if RPM is supporting these levels, we still need to patch RPM packets because of this. So this is very popular construction. And it's false on V2 because it's not exactly V2. So I think there are like hundreds of packages use these conditions, obviously. So we have to do something about this. We don't want to contribute to 100 packages. I think these decisions should be made somehow and it should be updated. So currently, the proper way to do that is to use such macros, because this expands to all the versions of this architecture, like without level, V2, V3, V4, and wherever. But there is no packages with this right now. It's supported in latest versions of Fedora and CentOS Stream 10, but no one uses this. So we had to patch RPM to just made V2 compatible with such conditions. So our V2, for V2, this works in our case. But in general, it should be like patched globally, starting from Fedora, I think, at some point. And last topic for today is Elevate. So originally, CentOS doesn't support major releases, upgrades, so it's not possible to go from 7 to 8, for example. So 3 years ago, we started a project called Elevate that unlocked this possibility. So Red Hat allows to do that for RHEL, but this tool just doesn't support any other operating systems. We take it, patch it on our side. The cool thing is that we don't only support AlmaLinux there, we support all distributions in ecosystem. So we maintain soft fork of it in our GitHub org. We unlock support for non-RHEL, as I said, and we also unlock support for third-party distributions, repositories, which is also not supported in original lib2. So we support Apple, which is huge because you will never see system in production without Apple, obviously. And also Docker, MariaDB, and so on. So this list can be easily extended. So it's very easy to contribute into Apple, into Elevate. So here's the situation right now, what options you have. So you can go from CentOS 6 even to CentOS 7, then you have to choose where you should go. There are some options like AlmaLinux, CentOS, Oracle, and Rocky. And then go the same operating systems like to the next versions. So currently, we even support AlmaLinux 10 beta. Obviously, it's not stable, it's not for production, but we're ready for that, and we're ready for testing. And this picture is like before today, because today I'm happy to announce that we now support CentOS Stream 10 as well. So this is requested by community. I'm happy to announce it. I'm happy to see some feedback about this and contributions. Thank you. So yes, so contribution. So we maintain two main repos in our space, which is like lib repository. It's fork, it's actions, all the like additional stuff to support third-party repos, to support like additional distributions goes there. Also, we have lib data. It's configuration files, so with third-party repos and so on. So if you want to add third-party repo support, you should go to lib data. Contribution guides how to do guide how to do this also available there. So this is actually what we do every day. So if this is what your heart wants, welcome to our SIGs. We have a lot of them, a lot of places to contribute. We will be happy to see you with us. Thank you.
Thanks a lot for the presentation. You got my attention directly as I saw bringing back KVM hypervisor role on Power. But it was in the slide about AlmaLinux kitten, so it's just like in the rolling CentOS AlmaLinux 10 stream, like whatever. Do you have planned to backport that to AlmaLinux 10 or even back to AlmaLinux 9? Because I would be really, really interested into that for CentOS Infra myself.
Okay, so that's why we did a kitten. So we collect feedback. So if it's interesting, so yeah, obviously this should go to 10 stable. About 9, okay, we need to discuss. So.
That started as a request from Lance at Oregon State, so talk to him. Yeah.
Thanks. About the V2 microarchitecture thing, one thing you may want to consider is working in Fedora to get the macro fix there. Like that's the kind of change that somebody with Proven Packager can do fairly easily.
Yeah.
Because they can just set all of the packages at once. It would need a change proposal and it would need a bit of work, but that would prep you quite nicely for the future.
Yeah.
It's not that much work, come on.
Okay, thank you.
Maybe a minor correction. A change proposal is not needed for this kind of thing because a mass back file change that is like a quicker process is also good enough.
Even easier then.
Okay, great. That would be very nice. Yeah, recently we started considering to rebuilding the whole Apple for V2 as well, because as I said before, it's very hard to find any system without Apple. So AlmaLinux for V2 means nothing without Apple for V2, obviously. So okay, we have RFC for that on GitHub.
And all the work for V2, etc., will be clearly a different repository and different ISO image, etc.
Of course.
For the kernel, when you mentioned that you enable back everything that was disabled upstream in RHEL, is that in the normal kernel so that you can just plain install directly, or is that a different media set?
It's stock kernel.
Oh, so your stock kernel in AlmaLinux enable back everything. So, okay,
yes.
Good, perfect. Thank you.
Thank you.
Any more questions? Thank you so much, Andrew.
Thank you.
All right, I think we're running just on time here. So we have our last session of the day, and then we'll start tomorrow morning again. We have Seteshwar Vashisht, a senior software engineer at Red Hat, and František Lachman, a principal software engineer at Red Hat, will be talking to us about OpenScanHub and packets. So welcome.
Yeah, so let's start with a quick quiz. How many of you people run static analysis tools on upstream projects? Something like Coverity. Okay. How many of you run them on downstream changes? On package updates, yeah. Okay. And how many of you have fully automated the process? Yeah, the real people are raising hands. Yeah, okay. So let's set. So what are we going to talk about? So I'm going to talk about OpenScanHub. Then Franta will talk about packet. We'll talk about how does the integration work, and then some of the ideas CentOS Stream and its derivatives may take away. And we'll take questions at the end. My name is Hitesh, or I'm a package maintainer in the RHEL group at Red Hat, and I'm one of the contributors to the OpenScanHub project.
Hello, I'm František. I'm a product owner of the packet team in Red Hat, and I'm involved in various automation efforts around Fedora, CentOS Stream. And thanks everyone for being brave and finishing the end with us. So we'll try to be quick.
Okay. So what is static analysis? So static analysis is the analysis of computer programs performed without executing them. So you have a tool, you have a source code, you give the tool to the source code, you give the source code to the tool, and the tool will tell you whether there are any bugs in the code without executing the code. And some of you may be using some of the tools already, like CPP check, shell check, or maybe the most famous Coverity. So what is the problem we are trying to solve? So the problem lies in fragmentation. And the problem with these tools is that these tools are developed independently of each other. They have different target audience. For example, shell check is towards bash or like any shell. And there are different communities or people behind these tools. So let's talk about the service idea here. So what if we can build a service that can run some of these analyzers on the code base, collect all the reports at a single place, and make it easy to analyze them? And that is OpenScanHub. So what is OpenScanHub? OpenScanHub is static analysis as a service. It is open source, so it's licensed as GPL v3. It became open source in 2023, in June. And it's not limited to any specific programming language. It can scan any type of code. It's fully automated for RPM packages. And by fully automated, I mean you have the SRPM, you give SRPM to the service, and the service knows how to build the SRPM. You do not need to specify the build rule. And one of the key features of OpenScanHub is the ability to do differential scans. So what is a differential scan? Imagine you have a package, and there's an update on the package. Let's say there's an old version of the package and there's a new update. And you only want to find the defects or bugs that may be introduced on newer version. So you can sort of perform a differential scan, and a result will only contain the bugs that may be there in the newer version. It will skip all the defects that may be there in the older version. And it's extensible. For example, we support CPP check, shell check, but if you have an analyzer that we don't support already, you can write a plugin for it. And it can collect all reports at a single place, so it's a hub. And there's a famous acronym for this service. The famous acronym is SAST. But it can also find something that may not be a security issue, anything that can be coded through static analysis. So how does it work? So it's deployed publicly on Fedora infrastructure. The user requests for a scan. The service runs various analyzers on the code base and collect the results at a single place and give the results back to the user. And that's how it looks. That's the web UI, that's the home page of the service. You can access this service by going to openscanhub.fedoraproject.org. It's free for everybody. And the simplest way to use it is through the scan submission form. And you need a Fedora account to submit a scan. So once you log in, you can go to this URL at the bottom of the slide, and you specify the NVR. And the NVR, the source RPM for this NVR will be pulled in either from the Fedora Koji or from Stream Koji. And because what we do with the SRPM is that we rebuild the SRPM, and we rebuild the SRPM with static analysis tools like CPP check or like GCC analyzer or Clang analyzer. So the terminology we have here is mock build. So mock build means perform a full scan of the package, and mock profile specifies basically the build route. And in this case, we have specified EPEL 9 here because some of the static analysis tools are not there in CentOS Stream. You need EPEL for that. And if the scan is successful, you will get a report that will look something like this in HTML format. But we also support other formats, most importantly, serif. And if your task is submitted successfully, it will show up on the task list page. And as you can see, under the owner section, you can see Packet is one of the biggest users of OpenScanHub. Like all these scans are submitted automatically through the Packet service. And Franta will talk more about Packet now.
Okay, so let's take a look what Packet actually is. So the goal of our project is to get upstream, meaning like the developers, closer to the downstream distributions. And we have like two ways how we are trying to do that. One is providing upstream CI, and one is like helping maintainers, so getting the release back to the down the stream to the distribution. By upstream CI, we mean like providing downstream feedback, like the RPM builds, running tests on top of those, image builds and others, back to the pull requests and commits in upstream. With downstream automation, we are trying to get the release coming from like the Git forges for Fedora, EPEL, CentOS, and also like the CBS. Regarding that, there are a couple of other things that you can learn about these other use cases. So if you are interested in like SIG infrastructure, you can join me tomorrow before lunch. And if you want to parallelize and do something useful and eat the lunch in one time, so you can take a look how you can automate EPEL releasing with Packet. So this will be tomorrow. And also we are integrating Packet with OBS, which allows much more that we haven't been able to do. So we have a talk on Sunday on a distribution. So that's a joint talk and joint work with Dan Chermak from SUSE. But back to the upstream use cases. So you might see quite a bunch of familiar logos here, and that actually shows how Packet works. We are taking existing, usually single-purpose services and building on top of those like a user-centric workflows and provide a GitForge UI for that. And one of such service is newly OpenScanHub. So how it works is we are starting on a GitForge, and GitForge sends us information about like some kind of event to the Packet. Packet then triggers a scan in OpenScanHub. OpenScanHub publishes the results in Fedora messaging service. We are listening on that, meaning Packet gets the information about the result and provide it to the user. Sounds simple. So looking at GitHub page, so you get the new result on the pull request status as you are used to with other services. And on the check result page, like the detail page that is available on GitHub, you have like more details. You can either get directly to the OpenScanHub page, or you can get to the Packet dashboard. So looking at the Packet dashboard, you can have a detailed view on the right top corner, where you can see like some details and also get to the OpenScanHub. And one thing that you might spot is that there is a copper build thing there, and you might be wondering why we need a copper build there. is there for a reason, because to not waste resources, because the scans static analysis is quite extensive job to do, so we are like trying to save some resources by running the copper build beforehand. So once we know that the package can be actually built, it makes sense to run the analysis. So that's the first thing you might spot. And the second thing is the new findings. And that's the killer feature Situ already mentioned. Because you might been thinking like, yeah, all of this is nice, but I've been there. I've already tried to establish this new CI system to my code base with 1,000 of errors that I can't possibly fix, and I just got rid of that after a while. That's why we are using the differential scans, so you can get just the new findings that are easier to find, fix when they are introduced, and that can be like introduced into existing code base. So let's take a look how the differential scan actually works. I hope it's like clear from the name, but during the development you can take like 2 versions and scan both of them. One produces like this bug number 1 and 2, and the second version produces like these 4 bugs. And as a differential scan, so you like show just the new findings, just the bug number 3 and 4. So in the package code, package use case, we are scanning the pull request and like the pull request head commit, and also the commit on the main branch, like the branch that we are trying to merge the pull request into. So there are 2 scans going on, and we are providing the diff of these. But if you really need, since there are still these 2 scans going on, you can still get the full scan results if you really need. But usually you will just see the new findings, so you can fix them right away and don't need to introduce the new findings into the code base. From the package configuration point of view, in package we are defining like stuff what you want from package in form of so-called jobs. In this case, we are requiring like copper build jobs. If you have copper build defined for pull request and copper build defined for commits on the main branch, we'll run the scans for you out of the box. You don't need to know much about like this setup, as I don't know much about static analysis, so it's really handy to use. And you will get the new findings as similar as Situ mentioned already. If you want to play with that locally before or like in the same time when using service, there is also a command line, so you can play with that also locally using your own FAS account, Fedora account, to integrate with OpenScanHub instead of the package service that tackles the like authentication for you. So if you are interested how this will continue moving on, if we will invest in that, you can actually influence that. In package, we are heavily influenced by the demand of the users. So if you want us to continue working on that, have some like new use cases, let us know. If we know that there are plenty of people interested in this, we will spend the time on that. If there is no one interested, we will probably leave it like this. So it's a general thing in our project. So let us know what you think. We have this GitHub discussion thread specifically for this use case. You can maybe put a comment here. Hey, that's a nice thing, I'll play with that, or we are missing this or that. Now let's zoom out a bit and let's take a look at the stream of code coming from the upstream, from where the developers are, down the stream through Fedora and other distributions down there. So that's the current / past state where all the rel packages are being statically checked. So that's the current space, and we are missing all rest. With this effort, by open sourcing the OpenScanHub and also having this integration with Packet, we are going left, so-called shift lefting to the upstream. So the problems can be fixed when they are introduced into real projects, when the development happens. So with this, you can check the upstream code, which is like easier, quicker, less expensive to fix, comparing with the rel when the life cycle is like longer. So all this shift lefting is like make shorter loop. Now there are maybe plenty of other places where this can be introduced. I'll start with Fedora. Packet team suggested that it can also take care of in a form of Fedora change proposal to take care of the dist-git CI. So this might be then an extra step that if Packet can do that, we can also introduce the OpenScanHub integration to Fedora dist-git pull requests. For the rest, I'll let Situ describe them.
Okay, so when we're doing the integration with Packet, the idea was to shift left, be closer to upstream. But when we talk about Fedora and CentOS stream, the idea is quite the opposite. Like you have to shift right, be closer to distributions. So basically, every time you make a change to Fedora, every time there's a pull request to dist-git to Fedora or CentOS stream, we should be running differential scans on that. And yeah, the scan should be added to the pipeline. So right now, when we run the scans, we were running them internally. Before the package was released to RHEL, we were doing differential scans there. But ideally, we should be running them publicly. Every time there's a pull request open on CentOS dist-git, we should be running differential scans on that, and results should be visible to everybody. So the next question is how? And the first step is to submit the scan. And to submit the scan, OSS CLI this is the command to submit a scan. And OSS CLI is the command line tool for OpenScanHub. And this is the command to submit a differential scan. So use version diff build means perform a differential scan. And config specifies the build route. So it's CentOS stream plus APL9, because we need APL9 for static analysis tools. And one way to do is through the SRPM. So you have the SRPM, in this case, this is the target SRPM or the newer version of the package, and you specify the base SRPM, the old version of the package. So that's how you do it for SRPMs. Other way is through just specifying the NVRs. So instead of specifying the SRPMs, you just specify the NVR of the package. And the NVR will be pulled from either Fedora Koji or CentOS Stream Koji. And if the scan is submitted successfully, you will get a task ID. And once the task starts running, the status changes will be reflected on, will be published on the Fedora message bus. And the topic to listen to is underlined in the second step. And you should be reflecting the status in the CI. If the scan finishes successfully, you will get a link to the results. And you can find more details on the Fedora wiki page. There's a page for OpenScanHub there. All the details are there. And so this is the last slide. I'll end you with some references. So there have been several talks about OpenScanHub. The first one is a talk from DevConf last year, 2024. And it's around a 30-minute talk if you're interested in just OpenScanHub, a longer version of like the history or the ideas we had last year. Some of them we implemented, some of them we are yet to implement. So you can watch the talk from last year. It's on YouTube. Second talk was done at GNU Tools Cold Run, and it was a brief introduction to OpenScanHub. It mostly talks about how you can use it. And the third one is a talk, MUNI, it's from Masaryk University. And it was done before the project became, like the service part of the project became open source. but the underneath tools like CSMOC were already open source. So it's a talk from Kamil Dudka, who has been working on this project for more than a decade now. So he's the lead. So if you are interested in the core ideas or some of the core details, you can watch this talk. And there have been several blogs about it. First one is when we made the project open source in June 2023, it was an announcement of open sourcing the project. Second one talks about the integration with Packet. And third one is the announcement from the Packet team about OpenScanHub integration. And that's the homepage of the project. You can find more details there. And that's all. Thank you. Are there any questions?
Cool system, and thanks for the talk. Yeah, so just curious about this diff that's going on. Seems like, as you described, you have to find an association between bugs in the prior version and in the newer version, right? Despite the fact that source code is changing.
Yeah.
Are there any tricks there? Is that a trivial process?
So you basically rebuild the packages. So you first do the rebuild of the old package, and then you do a rebuild of the new package, and then you compare the output of the.
Yeah. So these are always like independent and identifiable. Like when your source code changes, you never get any tricks, any missed bugs or extraneous bugs.
I mean, what do you mean by missed bugs? Like, it's just basically a difference. It's a difference of the output of mock. Basically, what we have done is that we have written a wrapper over mock. So it's called CSMock. So that's the core tool we use. So what CSMock does is that it enables the static analyzers and just the rebuild. And we capture the output of CSMock, basically mock with static analysis, and we compare sort of a diff. Like and there's the name of the tool that performs the diff is called CSDiff. So basically, you get the text and that's differential scan. So
thank you.
I have two questions. One of them is continuation of the Tommy's topic. So if you do the rebuild of the old package, against what build root you're rebuilding it?
From the one, okay, can I go back?
Is that the same build root that the new package will be rebuilt with?
You can specify, like, either you can specify one build root. So either you can use one build root and both the packages will be built with that build root. Or for the old package, you can specify the old build root and then it will build against that build root.
Yeah,
but
because otherwise you're not really building the right thing, which is especially important if you are having old packages that cannot be rebuilt in the new environment. Take the Fedora mass rebuild recently with new GCC, where a lot of old packages could not be built simply because of the C23 changes there, right? So you have to keep the information about the build environment that was used in the previous build for this information. And the second question, this was a comment, not more like not a question, but this now a question. So how hard is to add other static checkers for other languages?
So going back to my answer, like, so mock does the build. We have the tool, it's called CSMock, which is a wrapper over mock, which does the rebuild. So we have plugins for that. For example, for shell check, we have the CSMock shell check plugin. For CPP check, we have CSMock CPP check plugin. So if you have, you just need to write a plugin for CSMock to add the new analyzer.
Mm-hmm. So for example, all this stuff with Python and JavaScript and Java and so on, can it be plugged into the same infrastructure?
Yeah, you just need to write the CSMock plugin. I think we probably even have some plugins for, I think, Python. I forgot the name. Yeah, also for Sneak and others. Yeah.
My question is mostly, I don't want to have this on my side. If I'm delegating this to OpenScanHub, and I just want to choose the options I run against my project, and maybe actually let it detect those features based on what libraries or what languages I'm using, in my code, because in reality, in any semi-complex or complex code, you will have a mixture of languages, and it would be good to test both C and Python and maybe Rust on top of that, and so on. So all of these things need to be in the same, ideally in the same flow, rather than us introducing like tens of dozens of scanners through the GitForge facilities.
Yeah, definitely makes sense. There are a couple of things, like one is like supporting those, so that should be done as a plugin. We would probably want to maybe get help in that space. Then there is like which plugins should be enabled, and yeah, please create an issue for that. That one, not sure if we can maybe decide like where this should, if CSMOG should decide what to run, or maybe like on package side we can maybe check or get it from GitHub. Like, yeah, maybe we can take a look at what's changed. So maybe it doesn't make sense to like always run all, or we can maybe like try to get from the projects what type of files is there and maybe run the specific one. Yeah, definitely makes sense. Currently not possible, but doable. There is a possibility to like also like tweak this, like for example like maybe put some flags already, but nothing like automagic for now.
Yeah, interesting talk. I think just kind of following on from the same thing, like all of this seems to be predicated on the assumption that, you know, the change upstream or the change in the package is what is interesting and most likely to cause a failure. You know, so, you know, you have a package, there's a change to the package, or you have a it changes in Fedora, or it changes in CentOS or whatever stream. Yeah. Whereas in my experience, like that's one source of where changes come from, but you know, the bigger source, the most problematic one, the one that really hurts, is when there's a new compiler, when there's a mass rebuild, when there's a new glibc, you know, which, yeah, you know, you're touching on a little bit by, you know, running against Fedora, but like, where I guess maybe this is something that your OBS talk talks about a little bit too, because there's more rebuilds there and more life with Tumbleweed. But like how much of that is, how much are you tracking changes to your build environment and therefore flagging, you know, this change to the build environment has broken all of these packages?
Yeah. Yeah, definitely this is just a part of like bigger picture, and we would like to see like maybe on a distribution side, that's why not only this upstream check is enough. So, but Bishik wants to probably.
Actually, if you look at the output, it's static analysis. So it's like analyzing the sources, and it's mostly independent of the environment. I mean, like for a given compiler version, you get
given compiler version, but compiler versions change. And when a compiler
yes, but if you take the same source RPM and you build it twice, different source RPMs, and you build it twice in the same environment, then you shouldn't see reports about issues that are actually related to the change in the environment. You should see changes related to the source code.
So there are actually.
I was just looking at the list, and it's obvious that those are not things that matter, that depend on the environment.
They actually matter when the compiler changes the defaults for semantics of that language. This is what happened with GCC 15, where they changed the semantics applied by default. And if you are not sticking to older C standards, you get differently treated in certain areas, which means that your code, which was, for example, working.
Yeah, so some types of code became invalid. They wouldn't compile, but
the code might become not invalid, but undefined behavior might be open at that point. And these analyses might show you something new, and that's good, but it wouldn't be triggered by just using the static analysis in itself. So you wouldn't see this difference between the previous and new run unless you really change the environment between them.
There are maybe like a couple of things we can improve on that side. One is like that C2 tries to run like mass scans regularly, so we can maybe like compare that like on a like bigger scope of packages and compare that regularly, not based on a like upstream change, but like regularly.
In Fedora, we do have cache for doing that. So using cache and adding a task to cache to run OpenScanHub through the cache would be a solution.
With package, we are looking at cache also for other reasons, but yes, still probably some time ahead, but we'll see. But if you know there are plenty of people that are interested in this, that's like increase the motivation for us to look into that.
So I have a question. Oh, okay, so sorry, go ahead.
Just add to one more point, like, so I did the last mass scan on Fedora in November, and then I used GCC 15 for that. I didn't use GCC 14. I was in discussion with David Malcolm. So we are already in talks with the tools team about how to work better with the mass scans and everything. But that's what I did only with GCC, not with any other analyzer. But you are right, like about the semantics.
Yeah, and at that point, if I remember, we had too many false positives reported.
So we are still working on it. We have some ideas, but you will see some updates in next few months.
Sorry to jump into there, but isn't it just that you would update your static checker for GCC 15 compatibility, and then run a mass rebuild on the whole package system to catch those issues in advance? So basically, anytime you make a modification or enhance a new, introduce a big new feature to your static analysis, then it is time to do a bulk run.
Yeah.
So
go ahead.
I was looking at the output for systemd 257 RC2, and the output, I mean, it seems to be all false positives, more or less. But to analyze them, I need to go to the source code. And I see a snippet and a line number, but actually I would have to always, figure out how to open the file externally and so on and so on.
You just want a better UI on the
like in Cavarity, right? I click and then it pops up a new screen, and then I click again and I go for 5 layers and I see, oh, okay.
Yeah, I mean, I agree with that. It should be expandable, like you should be able to.
Yeah, we are actually looking at that, and also with this serif format to like provide a nice view. Somehow it's also possible on GitHub side to like visualize it. Ideally, we would like to put it like where it belongs, like as a review, so on a specific line of the code. It's not so easy to map like the state of the code when it builds / checks to the original code. So it's not so simple because it doesn't match, but we would like to take a look at that because that would be really, really like where it should go. Okay, so thanks a lot for all the inputs.
Thank you. All right, that was our last talk of the day, and I'll take like 1 minute. I want to thank our sponsors again, Red Hat, Fedora, AlmaLinux, Rocky Linux, and Meta for helping us put on this event. We have no planned activities tonight, so go out and enjoy Brussels, and you'll start to see more of the FOSDEM people descending on the city tonight. Tomorrow night will be the waffle party. I'll give you some more details. It's in your inbox if you registered, but I'll give some more details on that tomorrow. We will start presentations. We'll have presentations all day tomorrow. The first presentation will be at 9 a.m. It'll be Fabian talking to us about CentOS Infra. You are welcome to come into our hallway space as of 8 tomorrow. There'll be coffee, pastries, fruit. If, like me, you like to have a more substantial breakfast, maybe you want to eat before that. But pastries and fruit will be out there. I'll be downstairs at the DoubleTree breakfast before that. So if you're in the room block, breakfast is included. That's it. I will see you all tomorrow.